Hi all, welcome to Go Classes. In this lecture, we will continue our discussion of gate PYQs of sequential circuits. This is sequential circuits gate PYQs part 3. So far, do you feel confident? Please let me know. So far, we have seen some concepts of sequential circuits and gate PYQs part 1, part 2, and this is part 3. In the future lectures also, in the remaining concepts also, you will feel very confident, but you just let me know. Please share your feedback in the comments whether you feel confident right now or not. Okay, so far whatever we have seen in the sequential circuit, all the gate PYQs that we have done, do you feel confident? Now let me tell you that on YouTube you can search Go Classes sequential circuit, and this sequential circuit gate PYQs part 1 also you will find, and part 2 also you will find. You can see sequential circuit gate PYQs part 1, sequential circuits gate PYQs part 2. So on YouTube you can search, on YouTube in the search box you can put Go Classes sequential circuit gate PYQs, or you can search Go Classes sequential circuit, and many more lectures of sequential circuit which Go Classes has uploaded you can find. Okay, this is our YouTube channel Go Classes for Gate CS. You can subscribe to it, and when you search Go Classes sequential circuit, then all the sequential circuit related topics, all the lectures that we have uploaded on the YouTube, you can find, you can watch them. For example, you can see this video. This is SR latch complete and easy explanation. Basically in this single video we have discussed all about SR latch, S bar, R bar latch, and also all the gate CS, all the gate electronics PYQs also we have discussed in this single lecture. Okay, so you can just search Go Classes sequential circuit and you can watch our sequential circuit lectures and also gate PYQs part 1, gate PYQs part 2. Now let's start our gate PYQs part 3. Let me quickly do some important recap. We have already seen in the previous lectures what is synchronous sequential circuit. The sequential circuits, they are basically are of two types, synchronous and asynchronous. What is synchronous sequential circuit? So the definition is very simple. Synchronous sequential circuit means all the flip flop, they are operated by the common clock. All the flip flop are operated by same clock signal, common clock signal. And asynchronous sequential circuit means flip flops, all the flip flop, they are not operated by a common clock signal. Means in the synchronous circuits we have common clock signal for all the flip flops, and in the asynchronous sequential circuits we have no common clock. So you can see in the synchronous circuits, because all flip flop are operated by a common clock signal, so all the flip flop, they will respond to the inputs at the same time. All the flip flop, they will change their state, they will change their output at the same time. So this is what is written here. You can see that in the synchronous sequential circuits, all the sequential elements, what is the meaning of sequential elements? Sequential elements means flip flops. So you can see in the synchronous circuits, all the flip flops, they will change their output at the same time, they will respond to the inputs at the same time, because all the flip flops are operated by a common clock signal. Very simple. Now let's see how to do analysis of synchronous sequential circuit. In the exam, if they give you some synchronous circuit, they give you means all the flip flop, they are operated by a common clock signal, then how to do the analysis of such circuit? So that is very easy. These are the steps. We have already seen these steps many times with help of many questions, with help of many gate PYQs. But let me just quickly tell you the analysis of synchronous sequential circuit. These are the steps. The first step is we will write flip flop input equation. Means for each flip flop we will determine the input equation. Then the step number 2, that is we will draw the state table. And the step number 3, that is we will construct the state diagram if there is requirement. Okay, now let's see the step number 2. We will draw the state table. Now in the state table, these are the columns that we are going to draw. Remember, state table is simply your truth table. It's simply your truth table for a synchronous sequential circuit. So let's see what columns we have in the state table. So you can see the first column will be external inputs, if any. Remember, in a synchronous sequential circuit, external input may or may not be there. If you have external input, then the first column we will put the first column for external inputs. Then present state of the circuit. What is present state of the circuit? That is flip flop output combination. This we already know that flip-flop outputs, they represent the present state of the circuit. Okay, so you can see the flip-flop output combination, the flip-flop outputs, that is your present state of the circuit. Then you can see flip-flop inputs. Okay, and then the next column will be next state of the circuit basically. And then the last column will be external output, if any. Remember, external input, external output, they are optional. In your given circuit, you have to check, do we have external input, do we have external output? If they are not present, then forget about them. If they are present, then you put columns for them. Okay, so you can see in the state table, these are the columns that we have. And if you put these columns in this order that I have mentioned, basically in this order you make these columns, then it will be easier for you. If you want, you can change the order also. For example, first you can put present state, then you can put external input. So small changes in the order you can do if you want. But if you follow this order, then it will be beneficial for you. I will tell you why. What is the reason? The reason is computation sequence. Okay, so let's see the computation sequence. But before that, remember, when we draw the state table for the synchronous sequence circuit, then the first column will be external input, if there are any. If we don't have external input, then forget about it. Then present state of the circuit, that is flip flop outputs, then flip flop inputs, then next state, and then external output. If there is no external output, then you forget about it. And then you can see step number 3, that is construct the state diagram. Now let's see the computation sequence. This is very important, so let's focus on computation sequence. In the computation sequence, first what we will do, with help of external inputs and present state, with help of these two, you can see external input and present state, with help of these two, first we will calculate the flip flop inputs. Okay, so this will be our computation number 1. Simple. You can see I have written here the computation sequence, that first, with help of external input and present state, basically with help of these two, we will find flip flop inputs. Okay, so you can see this arrow, that external input plus present state, with help of that we will find flip flop inputs. So this will be our first computation. And the second computation will be that with help of present state and flip flop inputs, with help of these two, okay, present state and flip flop inputs, okay, with help of this we will find this next state. Okay, this will be our second computation. This is going to be our second computation. If you have external output, if there is any external output, then remember, with help of these three we will find the external output. Okay, so I can say that with help of all these three, okay, with help of this also, and with help of this also, with help of these three, we will find the external output. Okay, this will be our computation 3. I hope you understood. But most of the time, the synchronous sequence circuit that you will see, they don't have external output. So that is the reason most of the time only two computations you have to do, computation 1 and computation 2. But just in case, you can see if there is any external output, then you can find this external output with help of the first 3 columns. Okay, means external input, then present state and flip flop inputs, with help of these 3 you can find the external output also. Okay, I hope you understood. This is the computation sequence. So we have seen the steps also, we have seen the computation sequence also. Very easy. I have written here, you can notice that flip flop input and flip flop present state. Okay, you can see this present state and flip flop input, with help of these two we will find the next state. Okay, so you can see basically this computation 2. Regarding this computation 2, this statement I have written here, that flip flop inputs and their present state will help us determine the next state of the circuit. Okay, so that's it. So this entire analysis for synchronous sequence circuit, this is very important. I hope you understood what are the steps. I hope you understood how to draw the state table, and in the state tables also what is the computation sequence. I hope you understood. So this is the complete summary. Of course, this is the recap, because in the previous lectures, in the gate PYQs part 1, part 2, and in the previous lectures, in the theory lectures also, conceptual lectures also, we have already seen how to do the analysis of synchronous sequence circuit. Okay, I hope this point is clear. So we have seen the recap of analysis of synchronous sequential circuit. Okay, you can just go through this, which in the previous lectures we have already seen this with help of many gate PYQs and with help of many examples. Okay, so very simple. Now let's continue our discussion of 100 plus gate PYQs on synchronous sequence circuit from gate CS, EC, EE, IN, instrumentation, and biomedical. So basically, from all the gate branches, the synchronous sequential circuit questions PYQs we are going to continue. Okay, a lot of PYQs we have already seen in the previous two parts, part 1, part 2. This is part 3, and let's continue the discussion of gate PYQs now. Now for each question, because each question is a gate PYQ, so for each question, pause the video, try to solve this question on your own. If you have already watched our gate PYQs part 1, part 2, you can see Go classes, sequential circuits gate PYQs part 1 and part 2. If you have already watched these two videos, then all the questions are doable for you. You can just pause the video, try to solve the question on your own, and then you can watch the video solution, the explanation, because I will provide the complete analysis. Some variations also I will provide for each question. Okay, so but I'm very confident that if you have already gone through sequence circuit gate PYQs part 1, part 2 by Go classes, then definitely you can solve all the questions that I have taken in this session. Okay, basically all the questions based on synchronous sequence circuit you can easily solve. Okay, let's solve gate electronics 2026 question. You can find this question on this link on the Gate Overflow website for EC. You can see ec.gateoverflow.in. On this website, you can find this question. So let's solve it. The question is saying, this is question number 35. You can see in Gate Electronics 2026. The negative edge triggered JK flip flop in the diagram also, in this logical symbol or in this logical diagram also, you can see this means negative edge triggered, correct? Okay, this is a JK flip flop, you can see, and this is operated by this clock, and you can see that this symbol means that we have negative edge triggered JK flip flop. So the negative edge triggered JK flip flop in the figure has JK inputs tied to logic high, means J and K, they are fixed, they are tied to logic high, means they are fixed at 1 1, JK equal to 1 1, and a square wave of 10 cycles per second. This is the frequency. You can see what is the unit of frequency? Frequency unit, that is hertz, or I can say cycles per second, correct? Okay, so you can see 10 cycles per second is applied to its clock. Okay, remember one thing, that cycles per second, this is hertz. So they can also give you like 10 hertz. So it's basically 10 hertz, I can say. Okay, so you can see cycles per second. This is the unit. This is the unit for frequency, and this is written as hertz. Okay, so I can simply say that we have a square wave of frequency 10 hertz is applied to its clock input. Okay, this is the clock input. The question is asking the frequency of the output Q in cycles per second. So a square wave with frequency 10 hertz is applied at the clock input, and we need to find the frequency of the output Q. For this output Q, we need to find the frequency. Okay, so this is actually a very easy question. So let's solve it. Let's assume that on this clock input, some square waveform we have applied, right? And we already know what is a clock signal. Clock signal is basically a continuous oscillating signal between level 0 and level 1. Okay, so this is a continuous oscillating signal, and clock signal, that is basically a square wave. Okay, so basically the question is saying that some clock signal we have applied. Okay, this clock signal we have applied here, very simple. And for this clock signal, the frequency is given to you. The frequency is 10 hertz, means 10 cycles per second. Remember, cycles per second, this is the unit, this is the unit of frequency, and this cycles per second, this we write as hertz. So you can see this clock frequency, that is 10 hertz, and this signal we have applied at the input clock, and we need to find this Q output waveform. Okay, for this Q output waveform, some waveform will be generated, correct? Okay, so some waveform will be generated, and we need to find the frequency of this, because the question is asking the frequency of the output Q in cycles per second, again means hertz. Okay, so you can see this frequency, I can say FQ, this is what we need to find. Okay, for this Q output, the waveform will be generated, and for this waveform, the frequency we need to find. So let's see. Now let me take the clock signal. Okay, so just take a clock signal, and then let's see what will be the Q output waveform. In our previous lectures, we have seen many questions based on, Q output waveform, where clock waveform is given to you, and we are finding the Q output waveform like this. So this is the clock, I can say. So this is, I can say this is basically clock, or I can clock signal, or I can say C. Now you can see one thing, that this JK flip flop, this is a negative edge triggered, correct? Okay, you can see this is negative edge triggered JK flip flop. So what that means? It simply means that this JK flip flop, it will respond to the inputs only at the falling edges. Okay, because the JK flip flop is negative edge triggered. So at the falling edges of the clock, at the negative edges of the clock, these are the falling edges. At the falling edges of the clock, the JK flip flop will respond to the inputs. Okay, and already it is given to you that J and K, they are fixed at 1. J and K, they are fixed at 1. Okay, so let me write it here, that J, K, they are fixed at 1. So you don't have to draw the JK waveform. Okay, if you draw the J waveform, that will be fixed at 1. If you draw K waveform, that will be fixed at 1. Okay, basically they are fixed at 1. J is fixed at 1, K is also fixed at 1. Okay, so you don't have to draw the JK waveform, because you can just keep this in your mind, that JK equal to J and K both are equal to 1, and this is fixed. Okay, now let's see the Q output waveform, correct? Okay, this is the circuit. Here you can see JK flip flop. So this Q output waveform, let's see. Now the initial value of the Q is not given to us, so you can assume either 1 or 0. It won't change the answer. Okay, the question is only asking the frequency of the Q output. So you can see, you can assume that initially this Q output, this was 0, or you can assume this was 1. Okay, both are perfectly fine, there is no problem. Okay, so let me assume that initially let me assume that this Q output waveform, or I can say this Q output was 0 initially. This is what I am assuming. Assumed initially the Q is reset, or I can say initially Q is 0. If you want, you can assume initially Q equal to 1 also. The answer will not change, the frequency will not change. Okay, so you can do that. Now you can see these are the falling edges, and we already know that JK flip flop given to you, that is negative edge triggered. So it means that on these falling edges, the JK flip flop will respond to the inputs, correct? Okay, and remember this JK equal to 1, J JK equal to 1 1, this is fixed, and you can see that this is the toggle combination. This is the toggle combination in JK flip flop. Toggle combination in JK flip flop. What it simply means? What it means? It means that Q next, the next state, the Q next, that will be complement of Q present. Okay, the next state will be complement of the present state. Correct? Simple. Okay. Now you can see initially the Q value, I am assuming that is 0. Now the JK flip flop is negative edge triggered. So at this negative edge, till this negative edge, you can see the JK flip flop will be inactive, or I can say it will not respond to the inputs, and it will remain in its current state. Correct? Yes or no? Because you can see that JK wave, the JK flip flop that is given to you, that is negative edge triggered. So means except except at this negative edge, all the remaining time, the JK flip flop, this will be inactive. It will not respond to the inputs. It will not respond to the input change also, and also it will remain in its current state. So you can see it will remain 0. It will remain 0. Okay, simple. Now you can see at this falling edge, the JK flip flop, this will respond to the input, and the input is JK equal to 1 1. So you can see this is the toggle combination. It means the next state will be complement of the present state. You can see at this negative edge, look at this negative edge, at this falling edge, the present state is 0. The present state, this Q equal to 0. So at this falling edge, the next state, the next output of the JK flip flop, that will become 1. Yes or no? So here you can see it will toggle. Very simple. So because JK equal to 1 1, so that is the toggle combination. Means every time what will happen, at every falling edge, what will happen? At every falling edge, the next output of the JK flip flop, or I can say the next state, that will be complement of the present state. So here you can see at this falling edge, the present state was 0, but the next state will become 1. Now remember, before the next falling edge, the JK flip flop, this will be inactive, and it will not respond to the inputs. So it will remain in its current state only. Okay, very simple. At this falling edge, again it will toggle. Means again the next state, that will be complement of the present state. Here you can see the present state is 1. So the next state will be 0. Because you can see JK equal to 1 1, this is fixed, and this is the toggle combination. So at every falling edge, at every falling edge this state will toggle, I can say. Okay, so you can see at this falling edge, because the present state is 1, so the next state that will become 0. Okay, and then you can see before the next falling edge, again the JK flip flop, this will be inactive, it will not respond to the inputs and it will remain in its current state. At the next falling edge, again it will toggle because JK equal to 1 1, that is fixed, and that is toggle combination. So you can see next state that will be complement of the present state. So at this falling edge, you can see the present state is 0, so the next state will be 1. Okay, so I hope you are getting the point that at every falling edge the state will toggle. At every falling edge the state is going to toggle. Okay, so like this is your Q output waveform. Now you can easily notice one thing, that in this Q output waveform, what is the cycle time, or I can say what is the clock period. You can see clock period means between two the time period between two consecutive rising edges, or the time period between two consecutive falling edges, correct? Yes or no? Okay, so you can see that the time period between two consecutive rising edges or between two consecutive falling edges, both are your clock period. So here you can see the clock period will be what. So I can say it's like, this is the from here, this is the rising edge and this is the rising edge, the time period between two consecutive rising edges, this is the clock period of Q. Okay, I can say this is like TQ, and you can see that this is TC. This is TC, means this is the cycle time of the clock, or I can say this is the clock period of the clock signal. Okay, this is the clock period of the clock signal, or I can say cycle time of the clock. And you can see this is the period or cycle time of the output waveform Q. And you can see this TQ, this is double of TC. Yes or no? This is also TC. This is also TC. And you can easily see that this TQ in one TQ, I can say in one TQ, or I can say in one cycle, in one complete cycle of this Q output, this is the one complete cycle of the Q output. In this one complete cycle of the Q output, you can see there are two cycles of the clock, correct? Or I can say this TQ, this is basically twice of TC. And you already know that frequency, that is 1 by T. Yes or no? Frequency, that is 1 by T. So I can easily say that the frequency of the Q output waveform, that will be half of the frequency of this clock signal. Yes or no? Half of the frequency of the clock signal. Very simple. Remember, frequency means what? Frequency basically tells you how fast the signal is changing. Okay, so if frequency is more, then the signal is changing very fast. And here you can easily see that this Q output signal, this is changing very slowly. You can see here there is rising edge, here there is rising edge. And you can see in the clock signal, if you see here there is, for example, here there is rising edge, here there is rising edge, here there is rising edge. So you can see the clock signal is changing very fast, and the Q output waveform, this is changing slowly. So I can say frequency of Q output waveform, that is obviously less than frequency of the clock signal. And the exact relation you can see, because you can see in one clock cycle, in one complete clock cycle of this Q output, we have two clock cycles of this clock signal. So I can say TQ equal to 2TC, and frequency is basically 1 by T. So I can say FQ, that will be FC by 2. Okay, half this FQ, the frequency of the Q output, that will be half of frequency of the clock signal. So the frequency of the clock signal that is given to you, that is 10 cycles per second. Okay, that is 10 cycles per second. So I can say 10 divided by 2, these many cycles per second. This will be your answer. So answer will be 5 cycles per second, or I can say 5 hertz. Okay, or I can say 5 cycles per second. So here the answer will be the frequency of the Q output waveform, that will be 5 cycles per second. Okay, I hope you understood. So this was such a easy question. Actually, I am explaining this question, that is the reason it took time. But if you notice, this question is so easy, because JK equal to 1 1, that is fixed. So it means that next state will always be complement of the present state. And you can see this JK flip flop, this is negative edge triggered. So means at every falling edge basically state will toggle. Okay, because JK equal to 1 1, this is the toggle combination. So at every falling edge, at every negative edge, the state will toggle. Okay, so you can very easily just do like this, that if you assume initially if you assume, let's assume Q equal to 1. Okay, let's assume initially Q equal to 1, you assume, let's assumed, okay, assumed initially Q equal to 1. Okay, means let's assume that initially the jk flip flop that is reset, or I can say q equal to 1. So sorry, reset means set, because q equal to 1 means set. So let's assume that initially we are assuming initially the jk flip flop that is set. Now you can see, because jk flip flop that is given to you, that is negative edge triggered, so at every falling edge the flip flop will respond to the inputs, and because jk equal to 1 1, this is fixed, and this is the toggle combination. This is the toggle combination. So you can see that at every falling edge the state will toggle. Okay, so you can see initially the q equal to 1, so at every falling edge it will toggle. You can see at every falling edge, at the next falling edge it will toggle, at the next falling edge it will toggle, at the next falling edge it will toggle, and so on. That's it. Now you can easily see here that the frequency, that is half of the frequency of the clock signal, because you can see, if you see the cycle time, this is the cycle time. Okay, you can see between two consecutive falling edges, between two consecutive falling edges, you can see this time duration, this is the cycle time, and you can see this cycle time, if you notice, this is double of the cycle time of the clock signal. Okay, so you can see this tq, this is double of the cycle time of the clock signal, and we know the frequency, that is 1 by cycle time. So I can say here the fq, that will be what, that will be fc divided by 2. Okay, so why, very easy. So like this you can solve. Okay, so this is a very easy question. Now let me tell you some variations in this question. What are the possible variations? The possible variations are that it doesn't matter if you have positive edge triggered or negative edge triggered. It doesn't matter. Okay, see, if you have, let's assume, positive edge triggered flip flop. Okay, let's assume that they give you that jk flip flop that is given to you. Let's assume that is positive edge triggered. Then will the answer change? What do you think? This is q bar. Okay, and let's assume that the positive edge triggered jk flip flop is given to you. Okay, here you can see this symbol, it means positive edge triggered. So if you have positive edge triggered jk flip flop and j equal to k equal to 1, that is fixed. J equal to k equal to 1, this is fixed. Okay, so in this situation will the answer change? Let's quickly see. The answer will not change. Okay, because you can see this is the clock signal. Okay, let's take this clock signal you take. Now our JK flip flop that is positive edge triggered means at the rising edges of the clock, the flip flop will respond to the inputs. Okay, so here you can see, you can assume that initially the Q value, let's assume that was 0. Initially I am assuming that flip flop is reset, means initially the Q output that is basically 0. Okay, now you can see, because JK equal to 1 1, that is the toggle combination. Okay, this is the toggle combination, and because this is the toggle combination, so the next state that will always be complement of the present state at the rising edges, because the flip flop will respond to the inputs only at the rising edges, because the flip flop is positive edge triggered. So you can see at every rising edge the next state will be complement of the present state. So you can see initially if the present state is 0, then you can see at every rising edge the state will toggle, at every rising edge the state will toggle. Okay, at every rising edge the state is going to toggle. Now again you can see, again here you can easily see that this is the cycle time of the q output waveform. Okay, and in one tq there are two tc. Okay, so again you can easily see that in one tq there are two tc, so the fq that will be fc by 2. So you can see the answer is going to be same. This is one of the variation. Basically I just want to tell you that whether you have positive edge triggered or negative edge triggered jk flip flop, as long as jk equal to 1 1, then next state will be complement of the present state. So at every active edge of the clock, whether you have positive edge triggered or negative edge triggered, at every active edge of the at every active edge of the clock the state will toggle. Okay, so very simple. And one more variation, let me quickly tell you, that is, if they give you, let's assume, instead of jk flip flop, if they give you t flip flop. Okay, instead of jk flip flop, let's assume they give you t flip flop. And in the T flip flop, let's assume they fix T equal to 1. Now you know that this T equal to 1, this is the toggle combination. In the T flip flop, this T equal to 1, this is the toggle combination. This is the toggle combination. So you can see if they give you, let's assume T flip flop and T equal to 1, they fix. Then in that case also, you will get the same answer. Okay, if you have a clock, this is the clock signal C. Whether you have positive edge trigger T flip flop or whether you have negative edge trigger T flip flop, it really doesn't matter. You can see whatever type of T flip flop you take, positive edge triggered or negative edge triggered. So if you fix T equal to 1, then what I want to say, that this FQ, this will be basically FC by 2. Here also FQ will be basically FC by 2. Because you can see T equal to 1, this is the toggle combination. And it simply means that at every active edge of the clock, the state will toggle. Okay. So whether you are positive edge triggered or negative edge triggered, at every active edge of the clock, the state, or I can say the output, this output Q, or I can say this state Q, this will toggle. Okay. So these are some variations of this gate electronics 2026 question. I hope you understood. Let's solve gate EC 2024 question. The sequence of states Q1, Q0 of the given synchronous sequencer circuit is. So in this question, a synchronous sequencer circuit is given to you because you can see the same clock signal is applied to all the flip flops. Okay, or I can say all the flip flop, they are basically operated by the common clock signal. Here you can see, and both the flip flop, they are basically positive edge triggered because this symbol means positive edge triggered. Okay, now the question is asking the sequence of states. Remember, the initial state is not given to you. The reason is because the question is simply asking you the state diagram. You just make the complete state diagram. Means for every possible present state, you find what will be the next state. Okay, so in the state table, for every possible present state, we are going to find what will be the next state. So this is what we are going to find. So let's solve it. Because this is synchronous sequencer circuit, we already know how to do the analysis of synchronous sequencer circuit. First, the step number 1, that is we will write flip flop input equations. Then step number 2, we will draw the state table. Now notice one thing. In this circuit, in this synchronous sequencer circuit, you can see there is no external input, there is no external output. Yes or no? You can see in this, we don't have any external input. We have only flip flop inputs. Flip flop inputs are there and flip flop outputs are there. But you can notice that we don't have any external input and there is no external output. Okay, so I can say that basically these you can forget here. This external input is not there. This external output is not there here. So we have only, in the state table, we will only draw columns for three entities, basically present state, flip flop input, and next state. And what is present state? This is the flip flop output. Okay, and then what we are going to do, first from present state we will find the flip flop input, then from these two we will find the next state. This is the computation sequence. Okay, so everything I have written here in this analysis of synchronous sequencer circuit. Okay, so let's solve this question now. Let's write the flip flop input equations. Basically the step number 1, we will write flip flop input equations. So tell me, what is T1 here? This flip flop input equation we are writing. So what is T1? You can see this is the OR gate and this signal is basically Q0 bar. Okay, so Q0 bar OR, and you can see this signal is basically Q1. So Q0 bar or Q1. And what is T0? What is T0? So T0 is basically, again, this is the OR gate. So you can see there is Q0, or you can see in this OR gate, the another signal is basically Q1. Okay, very simple, that's it. And the second thing you notice here, which flip flop is MSB, which flip flop is LSB. So you can see this is given to you, state is represented Q1, Q0. Okay, what this means? State is represented Q1, Q0. It simply means that Q1 is MSB and Q0 is LSB. Okay, so remember, this is the MSB flip flop and this is the LSB flip flop. Okay, now we need to find the state diagram. So let's see it here. We have found the flip flop input equation. Okay, and here this is the MSB flip flop and this is the LSB state. state is represented as q1 q0. Okay, and you can notice one thing, that for this flip flop, if I ask you what will be the next state, means q1 next. If I ask you, or q1 plus means q1 next. What this means, this q1 plus, what this means, this means q1 next, q1 next. Okay, so you can see, for this flip flop, if I ask you what will be the next state, then that will be determined by whom? For this flip flop, the next state will be determined by the present state of this flip flop and also the input of this flip flop. So remember, the q1 next, that will be determined only by t1 and q1. Okay, and second point, you can see, for this flip flop, this is the t flip flop, and for this, if I ask you what will be the next state, that will be determined by its present state and its input. So very simple point, that if I ask you what will be q0 next, then that will be determined by q0 and t0, t0 and q0. Okay, so simple, all these points. Now let's draw the state diagram, state table. State table. In the state table, first we will make the column for present state. Present state means flip flop outputs. Okay, so I can say that q1 q0, these are the flip flop outputs. So let's make the column for q1 q0. Then flip flop inputs, so these are t1 t0. Okay, you can see t1 t0. Then next state, that will be q1 next and q0 next. Okay, let me quickly write what we have already found. We have found this t1 equal to q0 bar or q1. Basically, flip flop input equations we have found, and this t0 is q0 or q1. Okay, so t0, that is q0 or q1, and t1, that is q0 bar or q1. Simple. Okay, now let's see what we need to find. We need to actually find the state diagram, correct? So to find the state diagram, the question is asking us to find the state diagram. And state diagram, what that simply means, that for every present state, we will find what will be the next state, correct? Okay, so you can see here, I will write all the possible present states, and then for each possible present state, I am going to find what is the next state. Okay, so remember, this is the present state, this is the present state, and this is the next state, and this is the flip flop inputs. So here you can see, I want a state diagram, complete state diagram I want. So I will write all the possible present states. The present states that are possible, these are 0, 0, 0, 1, 1, 0, 1, 1. These are the possible present states. Now for each of these present state, I will find what is the next state. Okay, for each of the possible present state, the next state I will find. So you tell me first, what will be this T1 column? You can see T1 is equal to Q0 bar or Q1. Okay, Q0 bar or Q1. So here you can see in the T1 column, that is Q0 bar or Q1. So that will be 1 here, because Q0 bar, that will be 1 or anything, that is 1. Okay, Q0 bar or Q1, so that will be 0 here. Q0 bar or Q1, here Q1 is 1, so it will be 1 1. Now what is T0? That is Q0 or Q1. So you can see that here Q1 is 1, so here it also will be 1, and this T0, that is Q0 or Q1. Okay, so here it will be 0 1. You can just see. Okay, you can see here Q0 or Q1, that is 0. Here Q0 or Q1, that is 1. Okay, so simple. Now we have, you can see from this present state, I told you that first from this present state we will find the flip flop inputs. This will be our computation 1. And what is the next computation? What is the second computation? The second computation will be that from these two columns we are going to find this column. This will be our computation 2. I told you that. Okay, so let's see here. You tell me that if this is the present state and these are the inputs, then what will be the next state? You can see, who will determine this Q1 next? Remember, Q1 next will only be determined by Q1 and T1. Okay, so Q1 next, that will be determined only by T1 Q1. And you can see in the T flip flop, if the T input is 1, then that is toggle combination, means the next state, that will be complement of the present state. So you can see when T equal to 1, then next state, that will be complement of the present state. So you can see if the present state is 0, then the next state will be 1. Okay, yes or no? Now notice one thing, that wherever T1 equal to 1, you can see here T1 equal to 1, here T1 equal to 1, here T1 equal to 1. Okay, so you can see wherever you have T1 equal to 1, there what will happen? The next state, Q1 next, that will be complement of the Q1. Okay, so I can say that it will be like here. And you can see when this T1 equal to 0, Then in the T flip-flop, if the T input is 0, then the next state will be same as the present state. So you can see when T1 equal to 0, then this Q1 next will be same as Q1. Next state will be same as present state. So I can say it will be 0. So this is the Q1 next. And what about Q0 next? Who will determine Q0 next? T0 and Q0? Yes or no? So you can see here T0, wherever T0 equal to 1, in the T flip-flop, if the T input is 1, then that is toggle combination, means the next state will be complement of the present state. So you can see wherever T0 equal to 1, then this next state will be complement of the present state. So I can say this Q0 next, that will be complement of Q0, so that will be 0, 1, 0. And you can see when T0 equal to 0, then the next state will be same as the present state. So I can say here this Q0 next will be 0. Very simple. Now let's draw the state diagram. So you can see if the present state is 0, 0, if this is the present state Q1, Q0. Okay, so you can see if the present state is 0, 0, then the next state will be what? Next state will be 1, 0. And you can see if the present state is 1, 0, then the next state will be 0, 1. Next state will be 0, 1. And you can see if the present state is 0, 1, then the next state will be 0, 0. If this is the present state, then next state is 0, 0. So you can see from here we will go here. Now which state is remaining? 1, 1. If the present state is 1, 1, then the next state will be 0, 0. So you can see if the present state is 1, 1, then next state will be 0, 0. Okay, so that's it. This is the state diagram. Notice one thing in this state diagram, this arrow simply means that if this is the present state, then next state will be 1, 0. What it actually means? It simply means that because here all the T flip-flop, these were positive as triggered. In this diagram, if you notice, the T flip-flop, these are basically positive as triggered. What it means that? It simply means that if you are in this state, if this is your present state, then after the next positive edge, okay, or I can say at the next positive edge, the next state will become 1, 0. Okay, so I can say from this state, after one clock cycle or after one clock pulse or after one rising edge, the next state will be 1, 0. Similarly, if this is your current state, if this is your present state 1, 0, then after one clock cycle or after one clock pulse or after one rising edge, the next state will be 0, 1. And similarly, if the present state is 0, 1, then after one clock cycle, I can say that after one clock cycle or after one rising edge or after one clock pulse, the next state will be 0, 0. And if your present state is 1, 1, the next state will be 0, 0. Okay, so once you are in this state, once you are in any of these states like 0, 0, 1, 0, 1, 1, okay, 0, 0, 1, 0, sorry, if you are in any of these states 0, 0, 1, 0, 0, 1, okay, then this loop will continue. Then you will never go to this state 1, 1. But if you are in this state 1, 1, then you will go to next state will be 0, 0, and then this loop will continue. So this is the state diagram. Now let's let's see what will be the answer. So you can see from 0, 0 we are going to, it's like this is the state 2, this is the state 0, and this is the state 2, and this is the state 1. It's like that. So from 0, 0 we are going to 1, 0, then 0, 1. Okay, so let's see what will be the answer. You can see from 0, 0 we are going to, this is wrong. You can see from 1, 1 we are going to 0, 0, then 1, 0, then 0, 1, then 0, 0. Yes, this is the correct. So you can see answer will be option B. So this is a very simple question. I hope you understood. Let's solve GATE EC 2023 question. In given sequential circuit, initial state are Q1 1, Q2 0. For a clock frequency of 1 megahertz, the frequency of signal Q2 in kilohertz is. So this circuit is given to you. This is synchronous sequential circuit. You can notice because the same clock signal is applied to both the flip-flop. Okay, we have two D flip-flop, and thus the common clock signal that is applied to both the D flip-flop. So you can see this is a, I can say that this is synchronous sequential circuit. This is synchronous sequential circuit. This is the first thing to notice. Now let's see the next. The question is saying that for this clock, the frequency is 1 megahertz. Okay, means 1 mega cycles per second. Hertz means cycle per second. Okay, so you can say 1 mega. Mega means 10 power 6. So I can say 10 power 6 cycles per second. Okay, this simply means 10 power 6 cycles per second. Okay, now You can see the question is saying the initial state is given to you, q1 1 and q2 is 0. Okay, and the question is asking the frequency of signal q2. We just need to find the frequency of signal q2. Means what you do, you find the waveform for this q2, and to find this waveform for q2, what you do, first you find the state diagram. Remember, state diagram always gives you more intuition about the circuit. If you notice, if you see the diagram, if you see the state diagram, if you see the state table, if you see these different entities, then the most intuition about the circuit, about the behavior is given by state diagram. So what you do, you just find the state diagram. Means first you find that for every possible present state what will be the next state. Then what we will do, then we will find the waveform. Okay, we will find this q1 waveform, this q2 waveform. Okay, because this initial state is given to you, that q1 1 and q2 0. Okay, so I hope you understood this. Remember, whenever some circuit is given to you and you want the most intuition about this circuit, if you want to understand the behavior of synchronous sequential circuit, then the best way is that you find the state diagram first. Okay, so let's see the state diagram first and then we will solve this question. We have already seen how to do the analysis of synchronous sequential circuit. The steps are: step number 1, that is we will write the flip flop input equation. The step number 2, we will draw the state table. You can notice one thing: in this circuit there is no external input, there is no external output. Yes or no? Look at this circuit, there is no external input and there is no external output here. We have flip flop inputs, we have flip flop outputs, that's it. Okay, so very simple, that here I can say that there is no external input, so forget about it. There is no external output, so forget about it. So you can see in the state table we will make columns for present state, flip flop inputs and next state. And then you can see from present state we will find flip flop input, then from these two we will find the next state. Okay, everything is written here. You can see the computation sequence is written here, and you can see what is the present state, that is the flip flop outputs. Okay, so then after the state table we will draw the state diagram also. So let's see the step number 1, that is we will write the flip flop input equation. So tell me, what are the flip flop input equations here? You can say d1. What is that? D1 is same as q2. Okay, you can see this d1, this is same as q2. And what is d2? Look at this d2, this d2 is q1 bar. Okay, you can see this d2, this is basically q1 bar. Okay, so we have d1 q2 and d2 q1 bar. And who is msb, who is lsb here? Actually, for this particular question it does not matter who is msb, who is lsb, but still you can see what you can do here. This is writing like q1 1, q2 0, this q1 q2, so you can assume that this is msb, this is lsb for this particular question, because it is asking the frequency of this q2 output. Okay, so here in this question it does not matter who is msb. Okay, you can consider this as lsb or you can consider this as msb, that is your choice. For this question the answer will not change. Okay, so let me assume that this is the msb. Let me assume that this q1 is msb and this q2 is lsb. Okay, so basically the state, so here I can say that state I will denote as q1 q2, because I am taking this q1 as msb and q2 as lsb. Okay, again I am telling you that you can assume q1 as lsb and q2 as msb. The answer for this particular question will not change, because here the question is simply asking the frequency of this q2 waveform. Okay, now let's find after this flip flop, after this step number 1, that is flip flop input equations. Now we are going to find the state table. So in the state table, first we will make the column for present state. Present state means flip flop outputs. Okay, so I can say that flip flop outputs means q1 q2. then flip flop inputs, so that is d1 d2. And then next state, that is q1 next, q2 next. Okay, and the flip flop input equation that I have written, let me write it here. You can see d1 is q2 and d2 is q1 bar. Okay, so basically our target is to draw the state diagram, right? This is our target. To draw the complete state diagram, what we are going to do, for every possible present state we will find what is the next state. Okay, what are the possible present states? The possible present states are, 0 0 0 1 1 0 1 1. These are the possible present states. Okay, here you can easily say that this is the present state column, and you can see this is the next state column, and these are the flip flop inputs. Okay, so now let's see here. First, these are the possible present states. Now, for each possible present state, we will find what is the next state. For each possible present state, the next state we will find. Okay, so you can see first, you can see from this present state, first we will find the flip flop inputs. So you can see this D1 equal to Q2. Remember this D1 column, this will be same as this Q2 column. Okay, so as it is, you can write because D1 is same as Q2. Now, next you can see this D2 is Q1 bar. This D2 column, this will be Q1 bar. So I can say it will be 1100. Okay, now you can see from these two columns, I can say from present state and from flip flop inputs, you can see we will find the next state. Okay, now notice one thing, that both the flip flop, they are basically D flip flop, and in the D flip flop we already know that the next state, that is same as the D input. Whatever is the D input, that will become the next state. Yes or no? So we already know that in D flip flop, what happens, that Q next, that is same as the D input. Okay, so here I can say that, for example, here what will be this Q1 next, this will be same as D1, and this Q2 next, here this Q2 next, in this D flip flop, what will be the next state? That means this Q2 next, this will be same as this D2. Okay, yes or no? So in the D flip flop, remember, whatever is the D input, that will become your next state. Okay, so I can say that next state is same as D input. So I can say Q plus, that is basically same as D. So Q1 plus, that is same as D1, and Q2 plus, that is same as D2. Okay, so very easily, what is this Q1 plus, this will be same as D1. Okay, this D1 you can copy paste here. And what will be this Q2 plus? This will be same as D2. So this D2 you can copy paste here. Very simple. So you can see that if this is the initial state, the next state will be 0 1. Okay, so let me draw the state diagram. State diagram is, you can see Q1 I am assuming MSB, and Q2 I am assuming LSB. So if initially, if the present state is 0 0, then what will be the next state? From 0 0, you can see if this is the present state, then next state will be 0 1. And if 0 1 is present state, then next state will be 1 1. And if 1 1 is present state, then next state will be 1 0. And if 1 0 is present state, then next state will be 0 0. Okay, that's it. This is the state diagram. I hope you understood. Now, once we have the state diagram, we can solve this question actually very easily, because the question is saying that this clock signal, this is a square wave. Basically, you already know this is a continuous oscillating signal between logic 0, logic 1. So here the question is saying that the frequency of the clock signal, that is 1 megahertz, and we need to find the frequency of the Q2 waveform. Okay, and initial state is given to, that is 1 0, because I'm assuming that Q1 is MSB. So I can say that Q1 Q2, this is the state of the circuit, and that is 1 0. Okay, so now let's see. Now first let me draw the clock waveform. Okay, clock signal waveform. Okay, so clock signal, here I can say, let me draw it. So let me draw the signal like this. Okay, now notice one thing, that both the D flip flop, these are positive edge triggered. Okay, both the D flip flop, this arrow, this simply means positive edge triggered. We have positive edge triggered D flip flops. Okay, so what it simply means, if both the flip flop are positive edge triggered, it means that at the rising edges of the clock, the flip flop will respond to the inputs. Okay, at the rising edges, at the rising edges of the clock, both the flip flop, they will respond to the inputs, and this is a synchronous sequential circuit. So notice one thing, that because the circuit is synchronous sequential circuit, means all the flip flop, they are operated by the common clock signal, and both the flip flop, these are basically positive edge triggered. What it simply means that both the flip flop, they will respond to the inputs at the same time. and they will respond to the inputs at the positive edges of the clock. Okay, very simple. So here, this is the clock signal that I have taken. Now, let's make the waveform for Q1, Q2. Okay, initially Q1, Q2, that is 1, 0. This is given to you, that initially this Q1 is given to you, this Q2 is given to you. This is 1, 0 that is given to you already initially. Means before the first positive edge. See, these are the positive edges. These are the rising edges where the flip flop will respond to the inputs. Okay, all other time the flip flop will be inactive and they will remain in their current state. They will not respond to the inputs, they will not respond to the input changes. But at the rising edges, the flip flops, the two D flip flops, they will respond to the inputs because both the D flip flops, these are positive edge triggered. Okay, now the question has already given to you that initially this Q1, Q2, initially Q1, Q2 is 1, 0. Okay, that is given to us. So initially this Q1 is 1 and this Q2 is 0. Okay, so remember initially we have 1, 0. This is given to us. This is given that initially Q1, Q2, that is 1, 0. Okay, correct. Q1, Q2 equal to 1, 0. Now let's see this state diagram. You can see, notice that from 1, 0 the next state will be 0, 0. From 0, 0 the next state will be 0, 1. Okay, yes or no? And what this state diagram basically means, let me tell you. You can see both the D flip flop, these are positive edge triggered. So I can say that if you are in this state, if the present state is 0, 0, then at the next positive edge, the state will become 0, 1. Then if this is the present state 0, 1, then at the next positive edge the state will become 1, 1. If the present state is 1, 1, then at the next positive edge the state will become 1, 0. And if the present state is 1, 0, then at the next positive edge the state will become 0, 0. This is what it means. Or I can say that if this is the present state, then after one clock cycle or after one clock pulse or after one rising edge, the state will become 0, 1. If this is the present state, then after one clock cycle or after one clock pulse or after one rising edge, the state will become 1, 1. Or I can say that from this 1, 1, the next state will be 1, 0. From this state 1, 0, the next state will be 0, 0. So I hope you understood the meaning of this state diagram. Now let's solve it. You can see that this is the clock signal and these are the active edges. So you can see the state will change only at the active edges. Remember, all other time the flip flops will be inactive and they will remain in their current state. So only at the active edges, the flip flops they will respond to the inputs and they will change their state. Okay, so you can see from this state 1, 0, what is the next state? From 1, 0, the next state is a 0, 0. Okay, so you can see at this rising edge, the next state will be 0, 0, means both will become 0. This Q1 will also become 0 and this Q2 is already 0, so it will remain 0. I hope you understood. Now let's see at the next rising edge what will happen. From 0, 0, what is the next state? If the present state is 0, 0, then at the next rising edge, what state will become? If the present state is 0, 0, then at the next rising edge, the state will become 0, 1. Okay, so now remember the state will become 0, 1. Already this Q1 is 0, so it will remain 0 and it will become 1. This Q2, it will become 1. Okay, simple. Now tell me, if the present state is 0, 0, 1, then at the next rising edge, what will become the next state? So you can see from 0, 1, the next state is 1, 1. So from 0, 1, the next state will be 1, 1. So you can see this Q1 will become 1 and this Q2 is already 1, so it will continue. Okay, now tell me, at the next rising edge, because both the flip flop, these are positive edge triggered, so only at the positive edges of the clock they will respond to the inputs, they will change their state. All other time they will be inactive and they will remain in their current state. So you can see at this present at this positive edge or at this rising edge, you can see this Q1 is also 1 and this Q2 is also 1. So from 1, 1, what is the next state? From 1, 1, the next state is 1, 0. Okay, so I can say next state that will be 1, 0. Already this Q1 is 1, so it will remain 1 and this Q2 will become 0. Okay, now we have 1, 0. Now tell me from 1, 0, what is the next state? From 1, 0, the next state is 0, 0. From 1, 0, the next state is 0, 0. Both will become 0, 0. Okay, from 0, 0, the next state is 0, 1. Correct. From the 0, 0, the next state that is 0, 1. 0, 1. This is 0, this is 1. Okay. And you can see that from 0 1, the next state is 1 1. From 0 1, the next state will be 1 1. Okay, I hope you are getting the point. And from 1 1, the next state will be 1 0. The next state will be 1 0. Okay, and so on. And from 1 0, the next state will be 0 0. Okay, so I hope you understood this. Now you can easily find what is the frequency of this Q1 output and what is the frequency of Q2 output. Okay, yes or no? It's very easy now. So you can say, tell me what is the frequency of Q2 output, because this is what question is asking. The question is asking frequency of the Q2 output, Q2 signal. Okay, so let's see the frequency of Q2 signal. First, you find what is the cycle time. Okay, you can notice one thing: cycle time, or I can say clock period, or I can say period time period of any signal. What is that? That is the time duration between two consecutive rising edges. So you can see these are the two consecutive rising edges. So remember this is your TQ2. Okay. And you can notice one thing, that in this TQ2, how many TC we have in, I can say, in one complete cycle of Q2. This is the one complete cycle of Q2, because you can see this is the rising edge and this is the next rising edge. So the time duration between the consecutive rising edges, that is basically cycle time. So I can say that this is basically the cycle time, or I can say this is the one complete cycle. So in one complete cycle of Q2, how many complete cycles of this clock signal are there? You can easily notice that here, you can see that from here to here, because the time duration between two consecutive rising edges, this is basically TC. Okay, this is TC, then this is TC, then you can see this is TC, and then this is TC. Okay, and you can notice that this TQ2, this is basically 4 TC. Okay, do you agree? Because you can see from here to here. Okay, so let me draw that basically from here to here. Okay, so you can easily see that this TQ2, this is 4 TC. And remember, what is 1 TQ2? 1 divided by TQ2, that is frequency, because frequency is 1 divided by T. Yes or no? 1 divided by cycle time. So from here, you can easily see what will be FQ2. FQ2 will be FC divided by 4. Okay, is this clear? See, simple point, because already we know that TQ2, the cycle time of Q2 output, or I can say the time period of the Q2 output, that is basically 4 TC. Okay, so here if I do 1 divided by TQ2, then that will be 1 divided by 4 TC. What is 1 divided by TQ2? This is the FQ2. FQ2 is equal to 1 divided by 4. And what is 1 divided by TC? That is FC. Okay. So this is what I'm saying, that if you have TQ2 equal to 4 TC, then because we know that frequency is equal to 1 divided by T. So from here I can say that FQ2, this is basically FC divided by 4. And what is FC? That is given to you the frequency of the clock signal, that is 1 megahertz. Okay, so you can see this is 1 megahertz divided by 4. And the question is asking the frequency of the signal Q2 in kilohertz. Okay, so you can see megahertz, you know that capital M, mega, this means 10 power 6, and kilo means 10 power 3. So here I can say it will be like 10 power 6 hertz divided by 4. Okay, I can write it, 10 power 3 hertz divided by 4. Okay, so here this will become kilohertz. This is going to become kilohertz. So finally it will become 1000 divided by 4, that is 250 kilohertz. This is the answer. Okay, so for this question the answer will be 250 kilohertz. The question is asking in kilohertz the frequency of Q2, so that will be 250. I hope you understood. And if the question asks you what is frequency of Q1 signal, what that will be? Tell me quickly. Frequency of Q1 signal also you find. If they ask you about the frequency of Q1 signal, so let's find basically FQ1. Okay, what that will be? So here you can see that from one falling edge to next falling edge, the time duration between two consecutive falling edges, that is the cycle time, correct? So here you can see that this is basically the cycle time. Okay, if you see from here to here, from here to here, this is your tq1. Okay, and in this tq1, how many tc I have? So you can see that I have this tc, then this, then this, and then this. Okay, so again you can see that 1 tq1 equal to 4 tc. Okay, so fq1, that is again, that is fc divided by 4. So again, remember the answer you will get, that will be 250 kilohertz. Okay, so that's it, very simple. This is the complete analysis of this question. So here, if I ask you what is fq2, that is also 250 kilohertz. And if I ask you what is fq1, that is also 250 kilohertz. So did you understand how to solve this question? Tell me. See, the question was very simple, that the frequency of the clock signal is given to you, and the question is asking the frequency of Q2 Q2 waveform, Q2 signal. Okay. So here what we are doing, first we are finding the state diagram, because the state diagram will give us the complete understanding of the behavior of this circuit. Okay, we will understand this circuit, how this is behaving. Okay, how this is changing the state. Once we understand this circuit, once we understand the behavior of this circuit, then we can solve this question very easily, because the initial state is given to you, that is, q1 q2 equal to 1 0. And then you can see we have already solved it. So you can see that you can just take the clock signal, and then you can draw the q1 and q2 output waveform, you can draw, and then you can easily find the relationship between the cycle time of q2 and also the cycle time of the clock signal. Then you can find the frequency of q2. I hope you understood. Is this clear? The complete analysis of this question so far, is this clear? Now let me tell you one very interesting point. This question we have solved, but let me tell you what is the official answer key. You won't believe what is the official answer key. So far we got the answer, that answer will be 250 kilohertz, or I can say basically 250 will be the answer. But let's see the official answer key. If you see the official answer key given by the GATE 2023, the final answer key, that was 250 or 500. They are saying that if your answer is 250, then that is also correct, and if you write the answer 500, that is also correct. How is it possible? We have already solved this question. After solving this question, we did not find any ambiguity. Do you agree? We found that answer is 250. So remember, if you write the answer 250, that will be correct, no problem. But they are also saying that 500 will be considered as the correct answer. Means they are considering 250 as the correct answer, as well as 500 as the correct answer. If you answer 250 or 500, you will get marks, otherwise you will not get marks. But what is the reason that they are considering 500 as the correct answer also? We already know that correct answer will be 250, but why? What is the reason they are considering 500 as the correct answer? What do you think? Can you think about it? Let me tell you what is the reason. Some students, they challenged this question, this GATE EC 2023 question. Some students challenged it with the following logic. See what logic they used. They used this logic, that look at this logical symbol of the D flip flop and look at this logical symbol of the D flip flop. The students challenged with this logic, that in this symbol, in this logical symbol of the D flip flop, here you are writing Q1 complement, and then you are writing bubble. Okay, first you are writing Q1 complement, then you are writing bubble. So some students challenge this question, and they are saying that because you are writing in this logical symbol of the D flip flop, because you are writing Q1 complement and there is bubble, okay, so it simply means that this Q1 complement with help of bubble, it will become Q1. Basically, students are challenging. Actually, students challenged it, and this challenge was accepted. So students challenged that, they considered this as inversion. They considered this as inversion, means already this Q1 complement is written, and some students said that they considered this bubble as the inversion. So Q1 complement followed by inversion, this will become Q1. Basically, this logic they used, that this D2 is equal to Q1. Okay, so you can see now what will happen with this logic. This D2 will become Q1, and what this D1 will become? D1 will be same as Q2. D1 will be same as Q2. Now you solve this question, and now if you see, the answer will be 500. The frequency of the Q2 output, that will be 500. What do you think? Is this logic correct? Does it make sense? This logic, does it make sense? Some students challenged this question using this logic, and the challenge was accepted, and they considered both 250 and 500 as the correct answer. What do you think? This logic, does it make any sense to you? What do you think? Actually, this makes sense. Okay, I will show you why this makes sense. This challenge actually makes sense, and that is the reason this challenge was accepted. And to be honest, the question maker who made this question was not thinking that the students will think like this, because the question maker was just thinking that these are the logic diagrams of the D flip flop. These are the logical symbols of the D flip flop. These are not connections like this. See, this is just a logical symbol for D flip flop. This is just a logical symbol for D flip flop. So the question maker was not thinking that the students will think that this is, inversion, and they will consider this D2 equal to Q1. The question maker was not thinking. So the question maker was thinking that answer will be 250. From the question maker's point of view, the answer will be 250. But when the students challenged it, then this challenge actually made some sense. So they accepted this challenge, and they considered this logic also, and they considered 250 as well as 500 as the correct answer. Okay, let me tell you, if you go through the standard books, then what are the notations that you will find? Actually, you will find many different notations for the logical symbol of the flip flop. Okay, I have written here, you can see many different screenshots I put here. Let me tell you, for example, this screenshot is from Maurice Mano. This screenshot is from Charles Roth. This screenshot is from the book by Floyd. And this screenshot, I think this screenshot is I think this is from one other book. Okay, I'm forgetting the name of the book, but basically I have taken screenshots of flip-flop notations, or I can say flip-flop logic symbols from different standard books. You can notice one thing, that, for example, look at this. This is from Charles Roth. This screenshot is taken from Charles Roth. Here you can notice what they are doing. This is the D flip flop. This is positive edge trigger D flip flop. This symbol means positive edge trigger, that you already know. Okay, and you can notice that they are writing Q. This is the main output, your Q output, and this is Q bar. And you can notice no bubble they are using here. Please notice in this symbol, in this logic symbol for the D flip flop, you can see they are writing Q bar. So there is no confusion. Do you agree? There is no confusion here. Similarly, there is no confusion here, because you can see Q complement, and there is no bubble here. They are simply writing that this is Q, this is Q complement. Simple, very simple. So there is no confusion in this Charles Roth notation. Okay, now let's come to Morris Mano notation. In the Morris Mano notation, you can see again there is no confusion, because what they are basically saying, that if this is Q, this is Q complement. Okay, see, this is the Morris Mano notation. This screenshot is taken from Morris Mano. Again, there is no confusion here, because it's like if this is Q, then this is Q complement, because they are not writing what is here inside. Okay, what is inside here, they are not writing. Correct. And notice another notation, you can see, look at this notation here. They are writing QQ inside. Look at this inside, what they are writing. They are writing QQ. And outside there is bubble. So you can see this will be simply Q. And this is Q, and there is bubble. Q followed by bubble, that will be Q complement. Do you agree with me? Again, there is no confusion here, because Q followed by bubble, that will be Q complement. Q followed by no bubble, that will be Q. So again, in this notation also there is no confusion. In this notation also there is no confusion. In this notation also no confusion. And you can see this notation from the book Floyd, and here also there is no confusion, because notice they are saying that this is Q, and they are not writing anything here. They are simply saying that this is Q complement. Means it's like this, that this is Q, this is Q. Now Q followed by bubble, that will be Q complement. So again, there is no confusion. This is Q, this is Q complement. Okay, but now notice, look at this. Okay, just focus here. You can notice there is a confusion here, because they are writing Q1 here, so no problem here. This will be Q1. But here they are writing Q1 complement. Inside they are writing Q1 complement. Then they are writing bubble. So it means, it makes sense that it is Q1. It is also Q1. It is also Q1. Yes or no? Because of this bubble, it makes sense. And of course it made sense. That is the reason the professor, they accepted this challenge. And let me tell you, from my research I found something more interesting. So we have seen the equivalent notations. Now in my research I found this interesting point. I found, you can see, in the Portland State University, this screenshot I found. You can go to this link and you can check it out. I found something interesting during my research. So you can see, look at this line, this blue line, what they are writing. They are writing that show the wrong way to draw the symbol, the logic symbol, with complemented output labeled q and complement and a bubble. See, they are explicitly writing in this Portland State University, in this, on this link if you go, then you can see they are explicitly writing what they are writing. They are explicitly writing that if you make the logic symbol like this for SR latch, actually they are discussing SR latch, but the same, basically the same thing applies on SR flip flop, JK flip flop, like that. Okay, what they are writing here, they are writing explicitly that this is the wrong way. Means if you do like this, J, K, Q, if you write like this, the q complement, see, notice q complement, and then if you put bubble, they are writing that, they are explicitly writing that this is wrong, this is wrong way. Okay, so very interesting point I am bringing to you. You can see, this I found when I was doing some research related to this question. Okay, then you can see, show the wrong way to draw the symbol, to draw the logic symbol with complemented output labeled q and complement. You can see q complement and a bubble. Okay, means you are writing q complement also and you are putting bubble also. Then what it will mean, it can mean that, okay, this is q complement, then there is inversion, so overall it will be q. So they are explicitly saying that this is wrong way. But in the gate exam, you can see, in this gate EC 2023, they use this wrong way. Okay, the Portland State University is saying that this is the wrong way, this is the wrong symbol, this is the wrong logic symbol for D flip flop. You can't do this. They are explicitly saying that this is the wrong way. And that is the reason there was confusion, and some students challenged it, and this challenge was accepted, and they considered both 250 and 500 as the answer. Okay, I hope this point is clear. So remember, there are some equivalent notations for flip flop in the standard books. For example, let me consider, like, for D flip flop, let me write, if you see the D flip flop, you can write, for example, QQ here, then you can put bubble here. There is no ambiguity here. Do you agree with me? Okay, there is no ambiguity. Very good. Now you can see equivalently, I can also say that, I can also write like this, that, okay, D, I can write q here, q complement here, and then I can write like this. Again, there is no ambiguity. Okay, agree? Again, there is no ambiguity. Very good. Now you can see the equivalent way. That is what I can do. I can draw the D flip flop. This logic symbol for D flip flop, I can draw like this. That I can write just Q here, or I just don't do anything. Means I just write Q here and I just put bubble here. That's it. Or I don't write anything here. Okay, I just don't write anything here. This is also perfectly fine. There is no ambiguity here also. Okay, so you can see all these are actually they have been used. You can see. Okay, all these have been used. All these symbols you can find in the standard books. Okay, so you can see this also you can find, this also you can find, and also, yes, this also you can find that. Okay, you have D flip flop, and then you are writing q here and q complement here. This is perfectly fine, because basically you are saying that it's like q, it's here you are writing, let's assume qq, then ultimately it will become q complement. Okay, so remember, here if I write q complement, that is fine, because I'm simply saying that, okay, this is q, this is q complement. Okay, so I hope you understood. So these are the equivalent notations given in the standard books, and clearly here it is explicitly written that this is the wrong way. Okay, this is explicitly written here. So I can say that basically this is the wrong way. Okay, now let's come back to this question. So let's see the alternative solution now for this question. I hope you understood what was the ambiguity and why students challenged this question and why this challenge was accepted. Now let's just solve this question quickly. So now here let's assume that this becomes, let's assume q1, okay, because there is a inversion. Some students thought that this was inversion, okay. So if you assume this, then in that case what will happen? This d2 will become q1 and this d1 will become q2, okay. And now in this case what will be the answer? Okay, so again let's quickly see what is going to be the state table, state diagram, everything. Let's quickly see this question now. So let me make the state table. So in the state table we have q1 q2, you can see we have q1 q2 and then d1 d2 and next state q1 next q2 next, okay. So simple. Now let's see. For every possible present state, we are going to find what will be the next state. And already we have this d1 equal to q2, d2 q1, d1 q2, d2 q1. Okay, yes or no? d2 q1, d1 q2. So simple. Now here, very simple that d1 is same as q2. This d1, this column will be same as q2 column. So it will be 0, 1, 0, 1. d2 is same as q1. This d2 column, this will be same as q1, so it will be 0, 0, 1, 1, okay. And we already know that in the d flip flop the next state that will be same as the d input, so I can say in the d flip flop whatever is the d input that will become your next state. So I can say this q1 plus this will be same as d1 and this q2 plus this will be same as d2, okay, simple. So now you can see if I make the state diagram, now the state diagram will be, if the present state is 0, 0, then next state will be, so here you can see q1 q2. I'm assuming that q1 is msb, q2 is lsb. So if this is the present state 0, 0, then next state will be 0, 0, okay. See, if the present state is 0, 0, then next state also will be 0, 0. You can see if the present state is 0, 1, next state will be 1, 0. From 0, 1, next state will be 1, 0. And you can see if the present state is 1, 0, next state will be 0, 1. And you can see if the present state is 1, 1, next state will be 1, 1, okay. So this is the state diagram that we got. I hope you understood. Now let's solve. So the question was asking the frequency of q2 waveform, correct? Okay, so what we are going to do, let me draw the clock signal, okay. So the clock signal, let me draw. And you can see the question has given both the d flip flop as the positive edge triggered, correct? Both are positive edge triggered. So at the positive edge, at the rising edge of the clock, the flip flop will respond to the inputs. Otherwise, all other time they will remain inactive and they will remain in their current state, okay. So you can see, and already the question is saying that initially this q1 q2 that is given to you, the initial situation, initially q1 q2 is 1, 0, okay. So you can see initially q1 q2 that is 1, 0, that is given to you. So initially q1 q2 that is 1, 0 means this is 1 and this is 0. This is initially, okay. So now let's see from 1, 0 what will be the next state. You can see if you are in the state 1, 0, next state will be 0, 1. if you are in the state 0 1, next state will be 1 0. Okay, so they will just keep going like this, that from state 0 1 you will go to 1 0, from 1 0 to 0 1. Okay, you will just keep going like this. So you can see, if the initially, if the initially the state is 1 0, then at the rising edge what will happen, it will become 0 1, it will become 0, and it will become 1. Okay, so you can see it will happen like this will become 0, this will become 1. At the next rising edge what will happen, from 0 1 we will go to 1 0. Okay, so you can see from 0 1 we will go to 1 0, we will go to 1 0. At the next rising edge what will happen, from 1 0 we will go to 0 1. Okay, from 1 0 we are going to go to 0 1. And then you can see at the next rising edge, from 0 1 we will go to 1 0. Okay, that's it. So you can see here what will be the Q2 frequency, the Q2 signal frequency. You can easily see that the time duration between two consecutive rising edges, or the time duration between two consecutive falling edges, that is cycle time. So you can see that this is the cycle time. I can say this is the TQ2. And in this TQ2, you can see that we have, this is the TC and this is the TC. So you can see that TQ2 that is equal to 2TC. Okay, so you can see TQ2, this is 2TC. And similarly, you can also find for TQ1. Okay, you can see this is the falling edge, this is the next falling edge. The time duration between two consecutive falling edges, that is also cycle time. So you can see that TQ1, if you notice, that is also 2TC. So finally, I can say that FQ2, or I can say FQ1, that will be basically FC divided by 2. Okay, means half. So the question was saying, what the question was saying here, that the clock frequency is 1 megahertz. Okay, so if I do half, then what will be the frequency? If I do half, so you can see that 1 megahertz means 10 power 6 hertz. Okay, so if I do half of that, so in kilohertz if I find, so it will be like, 100, sorry, 1000 and kilohertz. Okay, I can say 1000 kilohertz divided by 2, so that will be 500 kilohertz. I hope you understood. So simple. So you can see like this the answer will come 500, and 500 was also accepted as one of the answer. So I hope the complete analysis is clear. Okay, so for this question answer will be either 250 or 500. But tell me, what is better answer for this particular question? Which answer is better answer? See, to be honest, the 250 is the better answer, because please understand, this is just a logical symbol for D flip flop. Okay, so of course the question maker will not play this kind of game. Okay, please understand that the sometimes you have to think from the question maker point of view. The question maker is not going to play the games like this type of silly games. The question maker is not going to play, because just think about it. If you assume for a moment, if you assume that okay, d2 equal to q1, then why this means, then what this means, because this is not connected to anything. So it doesn't make sense, it does not make sense that okay, this is also q2, this is also q2, this is also q1, this is also q1. Okay, it does not make sense, to be honest. Okay, but still they accepted the challenge. They accepted the challenge because they made a mistake. Remember, they did not accept the challenge because this is correct interpretation. We got the answer 500, but this is not the correct interpretation. They accepted the challenge because they made a mistake. Because of their own mistake, they accepted the challenge. Otherwise, otherwise you can see the answer will be 250 only. The correct answer is 250 only. In the future also, you have to just solve from the 250 point of view, because remember, these are just logic symbols I told you. Okay, so this type of silly games, the gate professors, the IIT ISC Bangalore professor, they are not going to play this kind of silly games. If they want to make a tricky question, they will make a tricky question in some different way. They are not going to make a tricky question by doing this kind of games. Okay, so basically they just made a mistake, and they just rectified it by considering this 500 as also alternative answer. Otherwise the answer will be 250 only. I hope you understood this question. Let's solve GATE CS 2023 question. Consider sequential digital circuit consisting of T flip-flops and D flip-flops as shown in the figure. clock in, CLK-IN. This is clock input to the circuit. At the beginning, Q1, Q2, Q3 have values 0, 1, 1 respectively. Which one of the following values of Q1, Q2, Q3 can never be obtained with the given digital circuit? See, initially the state is Q1, Q2, Q3 equal to 0, 1, 1. So this is the present state, this is the initial state. Then the question is asking that if this is the initial state, then to which state the circuit will never enter? In which state the circuit will never enter? Means basically the question is asking that which state is unreachable from 0, 1, 1 state. This is what the question is asking. Did you understand that if the initial state is 0, 1, 1, then which state will be unreachable? This is what the question is asking. Now remember, here if you look at the circuit, this is synchronous sequential circuit because the common clock signal is applied to all the flip-flops. Okay, you can see this CLKIN, this common clock signal, this is applied to all the flip-flops. Okay, so here the first point is that this is a synchronous sequential circuit. Okay, this is the first point to notice. Next, you can also notice that all the flip-flop, these are positive edge triggered. Okay, all of them are positive edge triggered. For this particular question, it doesn't matter this detail that they are positive edge triggered. This doesn't matter for this particular question, but anyway, you can easily notice that all the flip-flops, these are positive edge triggered flip-flops. Okay, and tell me here Q1, Q2, Q3, which of them is MSB? Which of them is LSB? So here you can see this Q1 is MSB and this Q3 is LSB because they are first writing Q1. Okay, so here you can see that state of this circuit. Remember, state of any sequential circuit. This is the flip-flop output combination. Okay, so you can see here the flip-flop output combination, that is Q1, Q2, Q3. This is the flip-flop output combination. So here the state of this circuit will be Q1, Q2, Q3. State is Q1, Q2, Q3. And here this Q1, this is the MSB, and this Q3, this is the LSB. Okay, here you can see this is the MSB and this Q3 is the LSB. Okay, very simple. And initial state is also given to you. Now let's solve this question. We already know how to do the analysis of synchronous sequential circuit. These are the steps. You can see the step number 1, we will write the flip-flop input equation. Then we will draw the state table. Notice one thing here. In this circuit, there is no external input, there is no external output. Okay, look at this. Look at the circuit. So you can see there is no external input here. There is no external input signal and there is no external output also. Here we have flip-flop inputs and flip-flop outputs. Okay, that's it. So basically we have no external input here. We have no external output here. Okay, for this question we don't have to worry about external input and external output. So basically in the state table we will draw present state, then flip-flop inputs, and then next state. And then with help of present state, first we will find flip-flop inputs, and then with help of these two we will find next state. Okay, you can see this is the computation sequence. That first you can see that from present state we will find flip-flop inputs, and then from these two we will find next state. Okay, then we will draw the state diagram. That's it. So this is the analysis of synchronous sequential circuits. And remember, what is present state? For any sequential circuit, the present state, or I can say the state of the circuit, that is flip-flop outputs, or I can say flip-flop output combination. Okay, so that's it. Very simple. So let's write the flip-flop input equation. So tell me what that will be. So here, these are the flip-flop inputs. Okay, so here for a moment, let me assume that this is T1 because notice this is Q1, correct? For this flip-flop, the output is represented as Q1. So I can say that, let me call it T1. Okay, and this D is unique because remember there are two T flip-flop and there is only one D flip-flop. Okay, so but if you want, I can write it D2, no problem, because you can see the output of this flip-flop is represented as Q2, so I can write it D2. And you can see the output of this T flip-flop that is represented as Q3, so let me write it T3. Okay, I hope this point is clear. And you can see that Q1 is considered as MSB and this Q3, this is considered as LSB. So the state is represented as Q1, Q2, Q3. This is how state is represented, where Q1 considered as MSB, Q3 considered as LSB. Let's write the flip-flop input equation. So here what will be T1 here? You can notice T1, that is basically Q3 complement because there is inverter here. Okay, so you can see this Q3 complement. So T1 is basically Q3 complement. What is T2 here? There is no T2, there is D, or I can say D2. Okay, so you can see there is D, or I can say D2. Okay, so what is D2? D2 is same as Q1, correct? Simple. And what is T3? You can see T3. T3 is same as Q2. Okay, so that's it. We have found the input equations for each flip flop. Okay, now let's see the state table. Now, here actually, there are two ways to solve this question. Let me tell you. Because the initial state is given to you, that is 0, 1, 1. So, there are two ways to solve this question. Either you start from 0, 1, 1, means you assume that present state is 0, 1, 1, and then you find what is the next state. And then for that next state, you find what is the next state. Because remember, you need to find which state is unreachable from the state 0, 1, 1. Okay, from this state, from this present state 0, 1, 1, which state is unreachable. So if you start from 0, 1, 1, and then you find the next state, then for that next state you find the next state, then for that next state if you find the next state, if you do like this, then it might be possible that it will be time consuming. It might be possible. Let's assume, I don't know, but let's assume that from this 0, 1, 1, let's assume from this 6 or 7 states are reachable. Total, let's assume 6 states are reachable or 5 states are reachable. Then you can see, before you find what is the which state is never reachable, before you find this, a lot of time will be consumed. Okay, so there is another way in this type of question. There is another way, that is what you do, for each possible present state you find what is the next state, and then you make the state diagram. So basically there are two ways. Either you start from 0, 1, 1, or the method number 2, what is that? For every possible present state, first you write all the possible present states, then for every possible present state you find what is the next state, and then you draw the state diagram. Let me solve this question using both the methods. Then you can decide in the future, if a question comes, then you can decide which method to use. Okay, which is less time consuming, which is more time consuming, that you can decide. Okay, so let me solve this question first by considering this 0, 1, 1 as the present state, means I will start from 0, 1, 1. Okay, so let me make the state table. What is the present state? In the state table, I have columns for present state, flip flop inputs, and next state. So the present state, that is Q1, Q2, Q3. So you can see this Q1, Q2, Q3, this is the present state. And what are the flip flop inputs? These are T1, then D, let me call it D2, okay, so that there is no confusion, and then T3. And then you can see what is the next state. Next state is Q1 next, Q2 next, Q3 next. Okay, now let me also write the flip flop input equation that we have found. T1 equal to Q3 complement. T1, this is Q3 complement. What is D, or I can say D2? Okay, that is Q1. So you can see, and T3 is Q2. Okay, very simple. Now let's see what the present state that is given to you, that is 0, 1, 1. Q1, Q2, Q3 equal to 0, 1, 1. This is the present state 0, 1, 1. So let's start from this. So first, from this 0, 1, 1, what is the next state that we will find? Okay, so let's see this here. Let me make the state diagram. So initially, this Q1, Q2, Q3 is given to you, that is 0, 1, 1. This is given to you. This is the initial state. Okay, so from this initial state, what will be the next state? Okay, so let's find that from 0, 1, 1. So first, you can see from this present state, first we will find this flip flop inputs. Okay, so you can see that this T3 is Q2. This T3, this is same as Q2, means it will be 1. This D2, this is same as Q1, so it will be 0. And you can see T1 is Q3 complement, so that is 0. Okay, now let's see what will be the next state. Notice, for the D flip flop, this is very easy. You already know, in the D flip flop, whatever is the D input, that will become your next state. Yes or no? So you can see how to find what is this Q2 next. To find this Q2 next, you just see what is D2. Okay, because in the D flip flop, whatever is the D input, that will become your next state. or I can say this Q2 next, this will be same as D2. So I can say it will be 0. This 0 you can write as it is. Now, in the T flip-flop, you can see if the T input is 0, then the next state, that will be same as the present state. Remember, who will determine this Q1 next? This Q1 next will be determined only by T1 and Q1. So in the T flip-flop, if the T input is 0, then next state will be same as the present state. So you can see this Q1 next will be same as Q1. And who will determine this Q3 next? It will be determined by T3 and Q3. And you can see T3 equal to 1. This is the toggle combination in the T flip-flop. So you can see when T input is 1, then the next state, that will be complement of the present state. So you can see this Q3 next will be complement of Q3, so that will be 0. So you can see from 0, 1, 1, the next state will be 0, 0, 0. Okay. So very simple. Now, if this is the present state, means from 0, 0, 0, what will be the next state? Means you assume that this 0, 0, this is the present state. Okay, let's take this as the present state. Now again you find T1, D2, T3. So you can see that this T1, this is Q3 complement, and this D2, this is Q1, and this T3, this is a Q2. Okay, now let's see. Again you can see this D2, this Q2 plus will become D2. So I can say this Q2 plus this will be same as D2, because in the D flip-flop, whatever is the D input, that will become your next state. And you can see in the T flip-flop, you can see if the T input is 1, then state will toggle. If the T input is 0, then you will remain in the present state, means next state will be same as the present state. So here I can say that this Q1 plus, this will be complement of Q1, and this Q3 plus, this will be same as Q3. So you can see that from 0, 0, 0, we are going to 1, 0, 0. Now from 1, 0, 0, from this state to which next state we will go. So let's assume that this 1, 0, 0, this is the present state. Let's assume that this 1, 0, 0, this is the present state. Now if this is the present state, then what will be the next state? Let's find. So again you can see that T1 is Q3 complement, D2 is Q1, and you can see T3 is Q2. Okay, now let's see here. You can see whatever is D2, you just put this in the Q2 plus. Okay, and you can see if T equal to 1, then state will toggle. If T equal to 0, then you will remain in the present state. So you can see that Q1 plus, this will be complement of Q1, and this Q3 plus, this will be same as Q3. So you can see from 1, 0, 0, we are going to 0, 1, 0. We are going to 0, 1, 0. Now from this 0, 1, 0, where we will go? So what to do? You assume that this 0, 1, 0, this is the present state. This 0, 1, 0, you assume this is the present state. Okay, now you find what will be the next state. Can you notice this method is time consuming? Let me tell you, instead of this method, what you can do, you can write all the possible present states here. You can see there will be total 8 rows. Okay, you can write all the possible present states, then quickly you can find what are these columns. Very quickly you can find these columns also, then you can make the state diagram, and you can solve the question very easily. Okay, that method we will see, but first let's complete this method. So you can see from this 0, 1, 0, what will be the next state? So you can see this T1, this is Q3 complement, this D2, this is Q1, and this T3, this is Q2. Now you can see when T equal to 1, then this is the toggle combination in the T flip-flop. So the next state will be complement of the present state. So you can see it will be 1, 1. And you can see this Q2 plus, this will be same as D2. Okay, so you can see from 0, 1, 0, we are going to 1, 0, 1. From 0, 1, 0, we are going to 1, 0, 1. Now from this 1, 0, 1, what will be the next state? Okay, from this 1, 0, 1. So here you can see this T1 is Q3 complement, correct? Okay, next you can see this D2, this is Q1, and this T3, this is a Q2. Okay, now you can see this Q2 plus will be same as D2, and this T you can see equal to 0. So next state will be same as the present state. So that will be 1, 1. So you can see that now we are going to 1, 1, 1. So I can say that the next state is 1, 1, 1. Now from this 1, 1, 1, what will be the next state? So 1, 1, 1. Now you can see that this T3 is Q3 complement, so it will be 0, and the remaining will be 1, 1. And now here this Q2 plus, this will be same as D2, and you can see this T1 equal to 0. So next state, this Q1 plus, next state will be same as the present state. And you can see this T3 equal to 1. So this is the toggle combination. So I can say Q3 plus will be complement of Q3. So that will be 0. So you can see next state is 110. So from triple one, we are going to 110. 110. Okay. Now from 110, where we will go? Now let's see from 110 where we will go. 110 means now we need to find that from this 110 state, where are we going to go? Okay, so let's see. From 110, you can see T1, that is Q3 complement, so that is 1. D2, that is Q1. And T3, that is Q2. Okay, so here you can see that this will be 1. And T1, T3, they are 1, 1. So that is the toggle combination. So it will be, 0, 1. So 0, 1, 1. We are going to 0, 1, 1. Okay, we are going to 0, 1, 1 means we are going here. Okay, so now you can see from this initial state 0, 1, 1, which state is unreachable? Can you tell me which state is basically unreachable? You can see 0, 0, 1 is unreachable. Yes or no? So here you can see that from this state 0, 1, 1, from this state, you can never reach 0, 0, 1. Okay, you can see 0, 0, 1 state, we can never reach. So I can say answer will be 0, 0, 1. For this question, answer will be option A. Okay. But I just want to tell you that this method, this was not efficient method. Okay, let me tell you, there is a better method to solve this question. What is that? See, instead of starting from 0, 1, 1 and then doing one by one, what do you do? You just make the complete state diagram, you just make the complete state table. Means first you write all the possible present states, then you find for each possible present state what will be the next state. Okay, so remember, we have already solved this question. The answer is 0, 0, 1. We have found it. But I just want to tell you that there is more efficient method to solve this question. Okay, so let's see that efficient method. Let's see. So let's see method number 2. Method number 2. And in the method number 2, what you do? You just make the complete state table. Make complete state table means basically for all possible present states. Okay, for all possible present states, you make the state table. Now we already know that this T1, this is same as Q3 complement, and you can see that this D2, this is same as Q1, and this T3, this is same as Q2. Okay, these are the flip-flop input equations. Now I told you that method number 2, that is you make the complete state table for all possible present states. Okay, so it will be like this, that in the state table you just draw directly all possible present states. So you can see Q1, Q2, Q3, and all possible present states you directly write. You can see because Q1, Q2, Q3, we have 3 bits. So in there will be total how many rows? Total 8 rows will be there. Or I can say that what are the possible present states? The possible present states are, I can say 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These are the possible present states. Okay, now here you write what are the flip-flop inputs. So these are, T1, D2, T3, and these are the next states. You can see Q1 next, Q2 next, Q3 next. Okay, so here let me just quickly write what is this T1. This is the Q3 complement. T1 is Q3 complement, D2 is Q1. Okay, and what is D3? So the T3. What is T3? So T3, that is Q2. Okay, that's it. Now notice this method will be much, much more efficient and time saving. Why? What is the reason? Because now you can see this complete T1 column I can write immediately. Because what is this T1 column? This will be Q3 complement. So notice how we are saving the time. You can see We are saving the time because you write all the possible present states. These are the possible present states. This is present state possible. This is present state possible. So these are the possible present states. Now you can quickly draw this T1 column. This T1 is basically Q3 complement. So just do Q3 complement. That's it. What is D2? That is same as Q1. This D2, this will be same as Q1. So you can see, just do 0, 0, 0, 0, 1, 1, 1, 1. Now what is T3? That is Q2. This T3 column, that is same as Q2 column. So you can see 0, 0, 1, 1, 0, 0, 1, 1. Very simple. Now let's see the next. Now tell me, what will be this Q2 plus Q2 next? Because you can see in the D flip flop, whatever is the D input, that will become your next state. So you can see Q2 next, that will be same as D2. Correct? Okay, Q2 next, this will become same as D2. So here what you can do, you can just directly write this D2 column here. Okay, means this 0, 0, 0, 0. And then 1, 1, 1, 1. Simple. Now let's see what will be this Q1 next. It will be decided by T1 and Q1. So you can see in the T flip flop, wherever T equal to 1, then that is toggle combination, means next state will be complement of the present state, and wherever T equal to 0, then next state will be same as the present state. Yes or no? So you can just notice where T equal to 1, where T equal to 1, there what you do, this Q1 next will be complement of Q1. Yes or no? So here you can see wherever T1 equal to 1, there this Q1 next will be complement of Q1. So here I can say 1, here I can say 1, then you can see here I can say 0, and here I can say 0. And wherever T1 is 0, there state will not change, or I can say that Q1 next will be same as Q1. Okay, so here it will be 0, it will be 0, it will be 1, it will be 1. Very simple, right? Now let's see what will be Q3 next. The same point, Q3 next will be determined by T3 and Q3. In the T flip flop, if input T equal to 0, then state will not change, means next state will be same as the present state. If T equal to 1, then this is the toggle combination, means next state will be complement of the present state. So you can see that wherever T3 equal to 0, 0, there Q3 next will be same as Q3. So here I can say that it will be like 0, 1, and here also 0, 1. Okay, and you can see wherever T3 is 1, 1, wherever this T3, this is 1, 1, there this Q3 plus will be complement of Q3. Okay, so I can say it will be like 1, 0 and 1, 0. Okay, so that's it. Now I hope you understood. Now what the question was asking? The question was asking that if the initial state is 0, 1, 1, this is what the question was asking. You can see the question was saying that if the initial state is 0, 1, 1, then which state is unreachable? Correct? Okay, so now you can make the state diagram. Now the complete state diagram now you can make. Just tell me one thing. Do you think this method was more efficient? This method is more efficient because you are writing all the possible present states at simultaneously. Means, okay, in the beginning, you are writing all the possible present states. These are the possible present states. You are writing them. Then you can find these columns very quickly. You can find these columns very quickly. And now you can make the state diagram that if this is the present state, next state will be 1, 0, 0. Okay, so you can see if the present state is 0, 0, 0, 0, I can assume that this is state 0. Okay, so you can see Q1, Q2, Q3. If the present state is 0, or I can say 0, 0, 0, then what will be the next state? That will be 1, 0, 0. Tell me, if the present state is 1, 0, 0, then what will be next state? That will be 0, 1, 0. Okay, so from 1, 0, 0, we will go to 0, 1, 0. If the present state is 0, 1, 0, then what will be next state? From 0, 1, 0, the next state is 1, 0, 1. Okay, so the next state is 1, 0, 1. If the present state is 1, 0, 1, then what will be next state? From 1, 0, 1, the next state is 1, 1, 1. Okay, then the next state is 1, 1, 1. If the present state is 1, 1, 1, then next state will be 1, 1, 0. Okay, next state will be 1, 1, 0. If the present state is 1, 1, 0, then next state will be 0, 1, 1. Okay, next state will be 0, 1, 1. And if the present state is 0 1 1, then next state will be triple zero. Okay, then here next state will be triple zero. Simple. And now which state is missing? Total 7 states we have considered here. Now which state is missing? 0 0 1. This state is missing. So if this is your present state 0 0 1, the next state also will be 0 0 1. Okay, so you can see if your present state is 0 0 1, then next state also will be 0 0 1. So now you can easily solve this question. According to the question, this was initial state. Yes or no? So if this is the initial state, then which state is unreachable? 0 0 1. This is the unreachable state. Correct? Okay, so that's it. So this is how you can solve this question. I hope you understood. So remember, for the previous question, we have seen two methods, and now you can just realize which method is more efficient. And in the GATE exam, you can apply the more efficient method. Okay, I hope you understood both the methods. Let's solve GATE CS 2006 question. This question is interesting question because we have external input here. There is external input data, and this is based on synchronous sequential circuit with external input. This question we will solve using two methods. So please understand both the methods. Okay, and then you can decide which method is more efficient. I can say which method is more time saving. So we are going to solve this question using two methods. Let's solve this question. You can see this circuit is given to you. This is synchronous sequential circuit. What is the reason? Because the common clock signal is applied to all the flip-flops. We have 3 D flip-flops here. You can see, and the common clock signal is applied to all of them. All the D flip-flops, they are operated by the common clock signal. So you can see this is the first thing you can notice, that this is the synchronous. This is the synchronous sequential circuit. Synchronous sequential circuit. This is the first thing to notice. The second thing you can notice, that all the flip-flop, they are positive age triggered. For this particular question, this does not matter. Basically, this information will not help you, but you can just notice that all the flip-flop, they are positive age triggered flip-flop. Okay, this symbol means that they are positive age triggered flip-flops. Okay, so all the flip-flops, they are basically for positive age triggered flip-flops. Okay, and all the flip-flop are basically D flip-flop, and we already know that in the D flip-flop, you know that next state, that will be same as the D input, or I can say whatever is the D input, that will become your next state. Correct? In the D flip-flop, this Q next, that is same as the D input. That is same as the D input. Okay, so very simple. Now the question is saying that consider the circuit given in the diagram. This symbol means XOR. Okay, here you can see this symbol means XOR. The D flip-flop, they are initialized to zeros. Okay, clear means, remember, cleared simply means reset, and this is given to you that this simply means 0. Okay, so remember these words like clear, this is same as reset, and this simply means, I can say, 0. Okay, so you can see initially the state of the circuit, that is 0 0 0, means all the flip-flop, their output 0. Okay, so very simple. Now the question is saying the following data, this data is supplied to the data terminal. This data terminal is there. Okay, this data terminal is there. This is external input. You can see this is external input. So there is an external input data that is connected to D input of this flip-flop. Okay, so please understand there is a external input data that is connected to D input of this flip-flop. Okay, Q0. You can see it's like Q2, Q1, Q0. So I can say this external input data, this is connected to D input of this Q0 flip-flop. Okay, the question is saying that this data is supplied to the data terminal in 9 clock cycles. What it means? It means that in the first clock cycle, this data, this is equal to 1. In the next clock cycle, this data equal to 0. In the next clock cycle, this data equal to 0. Are you getting my point? In every clock cycle, 1 bit we are applying here. Okay, this data terminal, or I can say this data input, you can see in the first clock cycle, this data input is 1. In the next clock cycle, in the second clock cycle, this data input is 0. In the next clock cycle, data input is 0. Then in the next clock cycle, 1. In the next clock cycle, 1. Then next clock cycle, 0, 0, 0, 0, like that. So you can see that this data is supplied at the data terminal in the 9 clock cycles. I hope you understood this. That in every clock cycle, we are applying a single bit at this data terminal. Okay, this data input in every clock cycle, what is its value that is given to you. Okay, now the question is saying after the values of, after that, the question is saying after that means after 9 clock cycles we need to find the values of q2, q1, q0. Okay, I hope you understood. So the question is saying after that, the values of q2, q1, q0. Understood? So very simple. So basically after 9 clock cycles we need to find what is q2, q1, q0. You tell me q2, q1, q0, which of them is MSB? Here you can see it is given that q2 is MSB. Okay, you can easily see that this q2, this is MSB, because we are representing state like q2, q1, q0. This is how we are representing the state. So this q0 is LSB. So please understand this flip flop, this is LSB flip flop, and this flip flop, this is the MSB flip flop. Okay, simple, very simple. Now let's solve this question. I told you this question we are going to solve using two methods. So let's see both the methods. First, remember, because this is synchronous sequential circuit, we already know how to do the analysis of synchronous sequential circuit. These are the steps. The step number 1, we will write the flip flop input equations. The step number 2, we will draw the state table. Now notice one thing. In this question, in this circuit, there is external input data. Okay, there is this external input data. This external input now we have. So here you can see when we draw the state table, then the first column will be for the external input data here. Here the external input is data. Okay, so the first column will be external input data. Then present state. Present state means flip flop output. Okay, then flip flop inputs, and then next state. Remember, there is no external output here in this particular circuit. In this question, you can see, look at this circuit. We have external input we have, but there is no external output. We only have flip flop outputs. Okay, we have flip flop outputs, but there is no external output here. Okay, but there is external input here. So I can say that these will be the columns of state table: external input data, then present state, which is the flip flop outputs, and then flip flop inputs, and then next state. And what is the computation sequence that you already know? The computation sequence is that, you can see this is the computation sequence. The computation sequence is that first, with help of these two, external input and present state, from these two we will find the flip flop input. Then from these three we will find the next state. Actually, only from these two you will find the next state, because you can see that next state will be determined by flip flop input and flip flop present state. Okay, so very simple. Everything I have written here, you can see in this slide, everything is written. So now let's make the state table. And after making the state table, if there is any need, you can make the state diagram also. Okay, if there is no need, then you can skip. Otherwise, if required, then you can make the state diagram also. So first, let me make the state table. So the step number 1, that is, you will write the flip flop input equation. Okay, so you can see the flip flop inputs. First, let me label them. You can see for this D flip flop, the output is represented by Q2. The output is labeled by Q2. So let me call it D2. For this D flip flop, the output is labeled Q1. Let me label it D1. For this D flip flop, you can see the output is labeled Q0. So let me label it D0. Very simple. Now let's see here. What is D2? And remember one thing. Who is MSB? This Q2 is MSB. And this Q0, this is LSB. Okay, you can see Q2, Q1, Q0. So you can see Q2 is MSB, Q0 is LSB. Now let's see. What is D2? D2, that is same as Q1. D2 is Q1, very easy. What is D1? What is D1? See, D2 is Q1. And D1. D1 is actually XOR of Q2 and Q0. Okay, you can see that D1, this is XOR of Q0 and Q2. Okay, so I can say that Q0 XOR Q2. And what about D0? That is same as data. Okay, this this external input data. Okay, remember this data, this is the external input, and D0 is same as this data. Okay, I hope you understood this. So very simple. So you can see D0 is same as data, D1 is Q0 XOR Q2. Okay, so very simple. Now let's see. Now we will make the state table. Okay, let me make state table. In the state table, I told you the first column will be for the external input, that is data here. Okay, data. So the first column will be for external input data. The next column will be for present state. Okay, the present state, that is Q2, Q1, Q0. Here the state is represented. State means flip flop outputs. Okay, so you can say the state is represented Q2, Q1, Q0. This is how state is represented, where Q2 is MSB. Okay, so I can say that Q2, Q1, Q0. And then flip flop inputs. What are those? Those are D2, D1, D0. Correct? Okay. Then you can see next state, that is Q2 next, Q2 next, Q1 next, and Q0 next. Okay, that's it. Very simple. Now let's see. Now remember this data for the next 9 cycles. What is the data input that is already given to us? Okay, so let me write. You can see that this data input, you can see in the first clock cycle, this is 1. Correct? Read this. This is saying the following data, this sequence is supplied to the data terminal on this data terminal in 9 clock cycles. Okay, so you can see in this sequence, you can see in the first clock cycle, this we are applying this 1 at the data terminal. Then in the next clock cycle, this 0 we are applying at the data terminal, like that. Okay, so you can see that this, I can see this data terminal in the 9 clock cycles. What is happening? First we are applying 1. Then after that you can see 1 00 11. Then you can see 1, then 00, then 11. Then you can see total 40. Okay, then you can see 40 00 00. Okay, so very simple. So you can see, because you can see data input, this is given to you, that in the next 9 clock cycles, this will be your data input. This is the external input data, and in the next 9 clock cycles, this will be its value. Okay, simple. Now, what about the present state? Remember, this is the present state. Here, you need to understand that this is the present state. Present state simply means state of the circuit, simply means the flip flop output combination. Okay, so remember, this is the present state, this is the next state, and this is the flip flop inputs. And here we have, this is the external input. Okay, this was external input. Okay, and already it is given to you that the D flip flop, they are initialized to zeros. Okay, you can read this. The D flip flops, they are initialized to zeros, means the initial state is already given to you. This 0 0 0, this is the initial state given initial state. Okay, so here we have made the state table. Now tell me, what will be the computation sequence? The computation sequence, what that will be? The computation sequence will be that, okay, from these two we are going to calculate this flip flop input. This will be the first computation, yes or no? And what will be the next computation? The next computation will be that from these two, okay, I can say that from these two we will calculate the next state. So this is the computation sequence. I hope you understood. Now let's see. So you can see the initial state, that is 0 0 0. So this is what is given to you. So far what I have written what is given to me. This is given to me. Okay, now I need to calculate. So now let's calculate. So you can see already the state, the flip flop inputs, what are those? Let me quickly write. What is D2? You can see D2 is Q1. So D2 that is Q1. And you can see D1 is Q0 XOR Q2. D1 is Q0 XOR Q2. And what is D0? This is same as data. Okay. You can see D1 is Q0 XOR Q2 and D0 is same as data. Okay, very good. Now let's see. So here you can see if this is the present state and this is the data input, from these two we are going to find D2, D1, D0. So tell me, D2 is same as Q1, so it will be 0. You can see D1 that is Q0 XOR Q2, this D1. So that will be, you can see 0 XOR 0, that will be 0. And what is D0? That is same as data. This D0, this is same as data. So it will be 1. Okay, now notice one thing, something beautiful, that in the D flip flop, we already know that next state will be same as the D input. So remember, this Q2 next, this will be same as D2. Okay, this Q0 next, this will be same as D0. Okay, yes or no? This Q1 next, this will be same as D1, and this will be same as D2. So basically, this 0, 0, 1 as it is, I can write. Okay, once you get this as it is, you can copy paste here. Simple, because this Q2 next will be same as D2, Q1 next will be same as D1, and this Q0 next will be same as D0. So basically, you just have to find till here, then this same copy paste you can do here. Okay, now you can see, remember, initially this was the state, and initially data input was 1 in the first clock cycle. In the first clock cycle, this data input was 1. This was the present state, and this is the next state. Okay, do you agree? So now you can see, in the next clock cycle, the data input is 0, and the present state now will become 0, 0, 1. Do you agree with me? Now this will become your present state. See, very simple point. Initially, this was the present state of the circuit, means this was flip flop output combination. Okay, this is the present state, or I can say flip flop output combination was 0, 0, 0, and this was data input. So you can see the next state will become 0, 0, 1. Now you can see in the next clock cycle, the data input is 0. Now this 0, 0, 1 will become your present state. So tell me what will be next state now. You can see D2 is Q1. D2 that is Q1. D1 is Q2 XOR Q0. So you can see D1 that is Q2 XOR Q0. So that will be 1. And you can see D0 is data. So that is 0. Now this 0, 1, 0 you can just copy paste here. Okay, because in the D flip flop, the next state will be same as the D input. So you can see. Now remember, in the next clock cycle, data input is 0. And now this will become your present state. Yes or no? This 0, 1, 0 will become your present state. And the data input is 0. So now you tell me, D2, that is Q1. D1, that is XOR of Q0, Q2. So that will be 0. And D0 is data. So this 1, 0, 0 I can directly write here. Now you can see in the next clock cycle, data input will be 1. And now this will become your present state, this 1, 0, 0. Okay, now you can see. So you can see D2, that is Q1. And you can see this D1, that is XOR of Q2, Q0. So that will be 1. And D0 is data. Okay, so you can see this 0, 1, 0, you can just write here. Now this 0, 1, 0, in the next clock cycle, data input is 1, and this 0, 1, 0 will become your present state now. Correct? Okay, this is how the circuit is going basically. This is how the circuit is going through. So you can see initially this was the present state of the circuit, and data input was 1. So the next state will become 0, 0, 1. Now you can see, now in the next clock cycle, the data input is 0, and this 0, 0, 1 in the next clock cycle, it will become the present state. Then the next state will be 0, 1, 0. Now you can see in the next clock cycle, this data input is 0, and now this 0, 1, 0, now this will become your present state. Now the next state will be 1, 0, 0. So like this. Now you can see that this 0, 1, 0, this is your present state now, and data input is 1. So what will be the next state? You can see D2 is Q1, and XOR of Q0, Q2, that is D1, and you can see D0, that is data. So I can say this 1, 0, 1. Now next you can see this 1, 0, 1. So what will be D2? That is Q1. then you can see 0, and then you can see 0. Now remember, you can see, because this, notice this D0, this is same as data, right? So it will be 0 only, correct? Okay. Now let's see here. So you can see this 0, 0, 0, I can just write it here. Then you can see 0, 0, 0. Now, next what it will be? So you can see D2 is Q1. So it will be 0. And this will be 0. Okay. So you will get 0, 0, 0. Now remember, now it will be just 0, 0, 0, 0. Okay. Now it will be just 0, 0, 0. It will be just 0, 0, 0, 0, 0, 0. Okay. That's it. So what the question was asking? Notice. In the ninth clock cycle, this data input is 0. In the ninth clock cycle, the data input is 0. Okay, so you can see after the 9 clock cycle, what will be the state? The state will be 0, 0, 0. The state will be 0, 0, 0. I hope you understood. So what D0 will be? That will be same as data. So it will be 0, 1, 1. So this 0, 1, 1 we can write here. Then in the next clock cycle, this 0, 1, 1 will become the present state. So now you can see what will be D2, that will be Q1. And this D1, this is XOR of these two. So that will be 1. And you can see this D0, that is data. D0, that is same as data. So you can see 1, 1, 1. So I can write 1, 1, 1 here. Next, now you can see 1, 1, 1. And what will be this D2, that is Q1. So this will be 1. And then XOR of these two, that will be 0. And you can see D0, that is same as data. Okay, so notice that here in the next 4 clock cycle, basically this data is 0. So I can say this D0 will be fixed. This D0 will be fixed at 0. Okay, now you can see it will be 1, 0, 0. Now what about 1, 0, 0 here? So you can see what will be D2, that will be Q1. So it will be 0. And 1 XOR 0, that will be 1. So I can say 0, 1, 0, I can write here. Then 0, 1, 0 here. Then you can see D2 is Q1 and 0 XOR 0, that will be 0. So we got 1, 0, 0. Now 1, 0, 0 here I can write. And now you can see D2 is Q1. So it will be 0. Then it will be 1. And you can see it will be 0, 1, 0. Now remember what the question was asking. The question was asking that this is the data input for the next 9 clock cycles. And after that, after 9 clock cycles, what will be the state? So you can see after 9 clock cycles, this 0, 1, 0, this will be the state. Okay. Notice. In the ninth clock cycle, during the ninth clock cycles, during the ninth clock cycle, or I can say in the ninth clock cycle, this data input is 0. In the ninth clock cycle, data input is 0, and the present state is 100. And you can see the next state is 010. Means after 9 clock cycle, this 010, this is our answer. Okay, I hope you understood. So this is the complete analysis of this question, and you can see the answer will be 010. Answer will be option C. Okay, so did you understand this? Let me know. Now we will see the method number 2 to solve this question. In method number 2, we are going to make complete state table. When I say complete state table, it means with all possible external input plus present state combinations. Okay, for external input plus present state, you write all possible combinations, and then what you do, you make the complete state table, you draw all the columns, and then you make the state diagram. Okay, so already for 1 or 2 previous questions in this session, we have already made this complete state table, correct? In this question also, let's make the complete state table, and this might be more efficient. Okay, or if they ask you some question based on the state diagram, then also this complete state table you can draw. Actually, if the question is based on the state diagram, if they ask you some question related to state diagram, then definitely you have to draw this complete state table. So let's draw this complete state table now. When we draw the complete state table, then we don't care about what is this data sequence. Okay, at this data input, what sequence we are applying, just forget about it. Okay, this we will see when we draw the state diagram. Notice, first we will draw the state diagram after the state table, of course. Okay, the step number one, that will be we will draw the state table, then we will draw the state diagram. Once we have the state diagram, then we will see this sequence, then we will consider this sequence that we are applying at the data terminal. Okay, so let's solve this. And we already know what are the flip-flop input equations. So here you can see this is d2, this is d1, this is d0. And what is d2? That is q1. And what is d1? That is XOR of q0 and q2. And you can see what is d3. What is d0? D0 is your data. Okay, now let's see what will be the complete state table. When I say complete state table, let me write it here, that when I say complete state table, then for all the combinations of external input and present state, we are going to draw the combination, and then we are going to make the table. So in the complete state table, what will happen? These are the columns: data column, present state column. So for present state, what will be the column? This is the data column. And present state, that is q2, q1, q0, q2, q1, q0. This is the present state. Okay, then we have flip-flop inputs. Okay, these are d2, d1, d0. And then the next output, that is next state, that is q2 plus, q1 plus, and q0 plus. Okay, now let me quickly write here what are the flip-flop inputs. You can see this d2, this is a q1, d2 is q1. And what is this d1? This is q0 XOR q2. And what is this d0? That is data. Okay, now notice, it will be actually time saving, to be honest. Okay, so let's see here. You can see, let's write all the possible combinations for external input and this present state, or I can say flip-flop outputs. Okay, you can see present state means flip-flop output combination. So you can see that let's write all the possible combination for external input and present state. So what are the possible combinations? You can see, when this data is 0, then there are 8 possibilities for the present state. Do you agree? Okay, so let's actually let me draw in two different pages. Okay, so that it doesn't get very crowded. Okay, so let me draw this in two different pages. So let me draw here, when this data input is 0, then total 8 rows will be there. Correct? Okay, when this data input is 0, then 8 rows are there. Okay, and when data input is 1, then 8 rows are there. So you can see total will be 16 rows, because we are writing all the possible combinations of external input and present state. So total we have basically 4 bits. So you can see total 16 rows will be there. Correct? You can see 8 rows for data equal to 0, 8 rows for data equal to 1. And then you can see 0, 0, 0, 0, 0, 1. Then you can see 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, the same thing here also. You can see that it will be basically, it will be, I can say that I can just do like this, that 1, 1, 1, 1, 1, 1, 1, 1. Okay, that's it. So you can notice that there are total 16 combinations. You can see these are the 8 combinations where data equal to 0. These are the 8 combinations where data equal to 1. There are total 16 combinations. Now notice why this method is actually time saving. What is the reason this method is time saving? So you can see, because d2 is q1, so you can directly write this q1 column, this d2 column. Yes or no? D2 equal to q1. So this q1 column you can copy paste in d2. Correct? So you can see this q1 column you can just copy paste in d2. You can see this q1 column you can just copy paste in d2. Okay, next you can see this d1, this is XOR of q2 q0. So you can see 0 0 XOR 0, that is 0. 0 XOR 1, that is 1. 0 XOR 0, 0. 0 XOR 1, 1. You already know that XOR is for two inputs. XOR is 1 when they are different. Okay, yes or no? So here they are same, they are different, they are same, they are different, they are different, same, different, same. Okay, yes or no? So you can easily see that here same, then different, then same, then different, then you can see they are different, then they are same, you can see same, and then they are different, then they are same. Okay, correct. So you can see 0 1 0 1, then 1 0 1 0. So basically the same thing here when data equal to 1. In these 8 rows also the same thing, because d1 equal to XOR of q2 q0. So it will be, so 0 1 0 1, then 1 0 1 0. Okay, now what about d0? That is same as data. Okay, d0 is same as data. So you can see this data column, you can just copy paste in d0. Correct. So you can see 0 0 0 0 0 0 0 0. Okay, here also it will be 1 1 1 1 1 1 1 1. Isn't it very easy? Tell me. And you already know in the d flip flop, the next state that is same as the d input. Okay, so you already know that this q plus this will be same as d in the d flip flop. Okay, that you already know. So in d flip flop, so here I can say, so so what I can say, I can say that this q2 plus this will be same as d2, this q1 plus will be same as d1, and this q0 plus will be same as d0. Okay, so actually you don't even have to, just copy paste. You basically this is this triple zero, this same you will write here. Okay, you don't even have to write, you can just simply say that this is your q2 plus, this is your q1 plus, and this is your q0 plus. I hope you got it. Or you can just draw this. Basically I'm saying that you don't even have to draw the column for next state, because this is this for the d flip flop, the d input itself is your next state. Yes or no? So I hope you understood. So basically the same thing you will write here, 0 0 1. Okay, and so on and so on and so on. Okay, so you already know, the drill. So you know that, okay, q2 plus this is same as d2, and this q1 plus this is same as d1, and this q0 plus this is same as d0. Okay, so you already know. Now let's make the state diagram. How to make the state diagram when there is external input? In case of external input, how to make the state diagram? In the previous lecture also we have seen this. I told you that when we have external input, then how to make the state diagram? Very simple. In the circle, or I can say the nodes will be state only. The nodes will be representing the state only. So for example, if you have two flip flop, then every state has 2 bits. Okay, let's assume we have two flip flop. Then you can see two flip flop means every state will have 2 bits. And you can see now if you have external input and external output, then this is how the state diagram will be created. So you can see on the edges we will write what is the external input and what is the external output. So remember here, this means with inputs and outputs, it simply means here this is external input, this is external input, and this is external output. So when there is external input and external output, then this is how the state diagram will be made. You can see, for example, let's see the interpretation here. For example, if the present state is 0 0, means the flip flop output combination. Okay, if the present state is 0 0 and the external input is 0, then we will go to state 0 0, means next state will be 0 0 and output will be 0. Okay, are you getting my point? So means if your synchronous sequential circuit has external input as well as external output, then this is how we are going to draw the state diagram. So you can see in the state diagram, the circles or the nodes, they will be representing the state, and the edges will represent external input slash external output. Okay, for example, if the present state is 1 0 and if the input is 0, you can see this row, this edge, you look at this edge, so you can see if the present state is 1 0 and if the external input is 0, Then the next state will be 0 0 and output will be 1. Okay, the same thing you can understand. For example, if the present state is 0 1 and input, the external input, that is 0, then next state will be 0 0 and output will be 0. Output will be, sorry, 1. Okay, you can notice, for example, if the present state is 1 1 and if the input is 1, if the external input is 1, the next state will be 1 0 and output will be 0. Okay, so you can see this is how it will be interpreted. Okay, I hope you understood. In the previous lecture also we have seen how to draw the state diagram when there is external input, when there is external output. Okay, so let's do this. So once we have the state table, we have the state table, right? You can see 8 rows of the state table are here when data equal to 0 and 8 rows of the state table are here when data equal to 1. Total we have 16 rows in the state table. Now we can draw the state diagram. So let's see what will be the state diagram. So what is going to be the state diagram? Let's see. So you can see, remember, in the circles we will write the state only, and please understand that state is only this. Okay, state is represented by q2 q1 q0 only. So I can say that state diagram will be like this, that q2 q1 q0. If the present state is 0 0 0, then what will be the next state? If this is the present state, then what is going to be the next state? So you can see, from 0 0 0, this is 0 0 0, you can see. Okay, let's look at this. From 0 0 0, if the input is 0, then next state is 0 0 0. Okay, so please understand that if the input is 0, if the data input, okay, this data input, if that is 0, then we will go to 0 0 0. Otherwise, you can see, from 0 0 0, if the data input is 1, then we will go to 0 0 1. Okay, correct. So from 0 0 0, on input 0 we will go to 0 0 0, and you can see from triple 0, from state 0, on input 1 we will go to state 1. Okay, so you can see on input 1 we will go to state 1. Now let's see what about this state 1. From this state 1, on input 0 we will go to state 2. Okay, you can see on input 0 we will go to state 2. Okay, correct. You can see from this state 1, 0 0 1 means state 1. From this state 1, when data input is 0, when the external input is 0, then the next state will be 2. And you can see from state 1, on the input 1 we will go to state 3. Correct. So you can see on the input 1 we will go to state 3. Okay, now let's see from state 2, this is the state 2. From state 2, on input 0 we will go to state 4. Okay, so you can say from state 2, on input 0 we will go to state 4. Correct. From state 2 we are going to state 4 on input 0, and from state 2, on input 1 we are going to state 5. On input 1 we are going to state 5. Okay, now you can see what about the state, what about the state 3? From state 3, you can see from state 3, on input 0 we are going to we are going to state 6. From state 3, on 0 we are going to 6. From state 3, on 0 we are going to 6. And you can see from state 3, from state 3, on 1 we are going to state 7. On 1 we are going to state 7. Okay, now I hope you are understanding how I'm making the state diagram. Next, let's see. So now you can see that this state is over, this is over, this is over, this is over. 4 states are done. Now let's see the remaining 4 states. From state 4, this is the state 4. If the present state is 4, then on input 0 we are going to state 2. From 4 to 2, on input 0. From 4 to 2, on input 0. And you can see from state 4, on input 1 we are going to state 3. From state 4, on input 1, on input 1 we are going to state 3. on input 1 we are going to state 3, correct? Okay, from state 4 on input 1 state 3 we are going. Now let's see, what about the state 5? You can see from state 5 we are going to state 0 on 0. From state 5 we are going to state 0. From state 5 we are going to state 0 on 0. And you can see from state 5 on 1 we are going to state 1. On 1 we are going to state 1. Okay, I can say on 1 we are going to state 1. Okay, now let's see from state 6. Let's see that. So you can see from state 6 on 0 we are going to 6. From state 6 on 0 we are going to 6. From state 6 on 1 we are going to 7. On 1 we are going to 7. What about state 7? From state 7 we are going to 5 on 1. From state 7 you can see if this is the present state 7, then we are going to 5 on 1. We are going to 5 on 1. And you can see from state 7 we are going to state 4 on 0. From state 7 we are going to state 4 on 0. State 4 on 0. Okay, so that's it. Now the state diagram we have completed. Now let's see, once we have this state diagram, then how to solve this question. This state diagram you have. Now let's see how to solve. So you can see in the question the sequence that is given to you. Let's focus on that. So you can see we have this state diagram, correct? Now this is the sequence, and remember the initial state is 0 0 0. Okay, so now let's solve this. You can see this is the initial state, means initially you are standing here. Okay, initially you are standing here, and at the data terminal the input that we are getting in the in the 9 clock cycle, that is 1 0 0 1 1 then all 0. Okay, so you can see 1 0 0 1 1 then 4 0. Okay, yes or no? Now just tell me, very simple question I am asking. This is your present state, or I can say this is your initial state. You are standing here. So when you see 1, where you will go? When you see 1, from this state on 1 we will go to state 1. Now we are here. Okay, means after 1 clock cycle we will be here. Now let's see, now we are here, and from here on 0 where we will go? Means remember, now we are here. Now we are here. From here on 0 where we will go? Now we are here. Means after 2 clock cycle we are in this state 2. Now you can see from this state 2 on 0 where are we going? We are going to state 4. Now we are in the state 4. From state 4 on 1 where are we going? From state 4 on 1 we are going to state 3. From state 3 on 1 where are we going? From state 3 on 1 we are going to state 7. From state 7 on 0 where are we going? We are going to state 5. Sorry, from state 7 on 0 we are going to state 4. Now from state 4 on 0 we are going to state 2. From state 2 on 0 we are going to state 4. From state 4 on 0 we are going to state 2. So that's it. Now you can see at the end we are here. Okay, this is your answer. So the answer will be 0 1 0. The answer will be 0 1 0. Is this clear to everyone? Please tell me. So very simple. Remember, the question is very simple. This is our initial state, and now you can see in this initial state, if I apply the input 1, you can see in the initial state if I apply the input 1, then I will go to state 1. Then you can see from the state 1, if I apply the input 0, then I will go to state 2. Then from the state 2 on 0 I will go to state 4. Then from state 4 on input 1 I will go to state 3, and so on. You just have to track. You just have to keep you just have to track this state diagram, and then you will find your answer. So the answer will be 0 1 0. That's it. So this is the complete analysis of this question. I hope you understood. In this question we have we have drawn the state diagram also. This question we have solved using two methods. I hope you understood both the methods. Now I agree that method 1 was more efficient for this particular question, because for this particular question, if you make the state diagram, it will be time consuming. You can see the state diagram, this is becoming time consuming. But you can notice, if there is some question based on the state diagram, then you have to draw the state diagram, and for that this method 2 will be helpful. So basically the method 2 will give you some more knowledge, how to draw the state diagram, what is the meaning of the state diagram, how to track the state diagram, these things. But we have done the complete analysis of this gate question, so I hope you understood. So for this gate 2006 question, answer will be option C, and this is a beautiful question. We have solved it with complete analysis with with two methods. Okay, so I hope you understood this. So that's enough for today. In this session, we have solved some questions, and I hope you understood each and every question, the complete analysis of each and every question. I hope you understood, and we will continue solving these questions, the gate PYQs of all the branches on synchronous sequential circuit. These we will keep solving, okay, in the future. But now we will also start the remaining concepts of sequential circuit, like counter, register, flip flop conversion, and also there are some more concepts like, Mealy machine, Murray machine, and there are basically all the remaining concepts of sequential circuit. Now we are going to study in the next lecture onwards, and in parallel we are going to we will just keep doing these gate PYQs. Okay, so remember, we will study the remaining concepts also, and in parallel we will keep solving the gate PYQs that are remaining. Okay, so thank you everyone. Please share your feedback. Please put a comment. Please let me know, did you understand everything? So please share your feedback. So thank you.